So, you've all done your mocks in or don't you all got your exams back in honours anyway. And I was going to go through a few of the questions with some of yous, but it was just taking too long when we were doing it in person. So I'm just going to record myself kind of answering all the questions as best I can. And you guys can go through the ones that you want to look at yourselves. And if you still have an issue, you can let me know. It will be my first time seeing a lot of the questions. So I hope I don't make any mistakes, but I might do, particularly because in the mocks the wording can be ambiguous. It can mean one thing or another depending on how you're reading it. So I might just automatically read it one way, even though they meant it the other way. So that can happen. If there is an issue, or if there's a mistake, or if there's something that you think is a problem, let me know. But as I always say, let me know in a nice way. And if you're gonna be smug about it and try to hurt me with it, at least be correct. There was a couple of times where people tried to be like, Graham, you fucked up, and they were so confident with it, and then it turned out that they were wrong. There was something else like 20 seconds later that explained why I did what I did, or there was something they were missing. But yeah, no, in all honesty, if there is something wrong with it, let me know. Now, I'm not going to copy and paste all the questions onto the thing. I'm just going to, because someone sent me all the pictures of it, but I don't want to have to put all of their things onto the screen and then crop out their writing so that they don't feel embarrassed or anything by it, because I know that's kind of how people feel. And also just the effort of it. So paper one, question one, I'm just going to start doing it and we'll see how it goes. I'll probably pause it in a minute just to make sure that I'm actually recording it correctly so I don't do the whole thing without that. First one is just simultaneous equations. I'm sure everyone was okay doing this. You can probably skip this one. It's more so for me just to warm up. Yeah. So I'd say everyone was kind of okay with it. If you want to just check just to make sure, maybe there was an issue, I don't know. Let me know, as I said, if there's anything major. So I'm going to put A and B together straight away. Just because automatically there is a minus 2y and a plus 2y straight away. They can just cancel each other out. So we'd be left with x plus z equals 0, strangely enough, and that's going to be our D line. Okay, and it actually worked out here. This is a very special case scenario where I don't have to. Normally we'd put a second pair together from A, B, and C, but we don't have to here because our D line and our C line are already in the same kind of format. Now I'm going to rearrange the D line just the other way around. I'm just going to write the Z first and the X second. And you notice they're already in the same format. And all I'm going to do is I'm going to multiply the bottom line by 2. Because now it'll be 3z minus 2x equals minus 3 on top. Just watch handwriting, because you'll notice even on mine, you'll notice my z's and my 2's are starting to look similar. So yeah, just watch out for that one. But then if we do it this way, I wrote a z there. That was obviously meant to be an x. They cancel, and you're left with 5z. 5z equals minus 3. Is that what people got? No. What did I fuck up? This is where I pause it. You don't get to see me suffer. Okay, I see what happened. You're not going to believe me, but this isn't my fault. I took the question down wrong because the person I took it off of, instead of writing ABC, they wrote 1, 2, 3, which is a fair way of doing it. They did absolutely nothing wrong, but I just stupidly read the 3 that they did instead of the C as 3Z. So, how that's going to change is this shouldn't have been here either. And then this shouldn't have been here. So then this would have been 3, which means Z is equal to minus 1. I was so afraid that the very first thing I was fucking it up, and then I had a look at the thing and I realized what I was doing wrong. So that's one of them. And then what we're going to do is we're going to sub that back into one of the originals. I'm going to do the Z minus 2x equals minus 3, as I now know what it is, and that would be minus 1 minus 2x equals minus 3. Hike that over. Minus 2x is equal to minus 2. X is equal to 1. And then I'm going to sub that into the top one, sure. And then we'd have, instead of x minus 2y equals minus 3, we'd have 1 minus 2y equals minus 3. Just again taking one of the originals from the very start of the question. But I'm fairly certain everyone was kind of okay with all of those. And you can always check simultaneous equations by making sure that when you sub all three of those back into the original question, it should work for all three lines. Now, because they're all whole numbers, and because I can see on this person's one that two of my numbers match, I'm not going to check it, but it's fine. So normally for that, you'd have to put A and B together and then B and C, let's say, to get a D and an E, and you put D and E together. But here we didn't have to, because automatically the D line and the C line were the same format. They both had an X, they both had a Z, they both had a number, and we were able to just carry on straight away. Again, as I said, most people are okay with that, so it's, I did do a video on simultaneous equations already, so I suppose if you still have an issue, you can just have a look at that. So was that question 1, paper 1, obviously. I'll try when I'm setting up the actual video, I'll try put in timestamps along the way to kind of tell you when question 1 starts and when question 2 starts. I don't know how successful that's going to be. I don't know how to work YouTube properly, so we'll see. Now, part B of question 1 caused a lot of people an issue. Everybody seems to have an issue with this one, and it's understandable. It says, find the coefficient of the 1 over x cubed term in the expansion of, I'm assuming you all have the exam kind of in front of you that you can read as well, 1 over x to the power of 7. So the expansion means obviously expand that, and that could be to multiply it all out. But what we're going to do instead is we're going to use the binomial expansion thing. Hold on, let me get it up on the screen. Hang on. Wow, movie magic. So this is on page 20 of your log tables. It's not really done properly not really properly in Ratoath. I get why they don't do it. It's not a huge deal. It doesn't come up an awful lot. So they kind of skip it the odd time, just because it's like, this obviously looks horrendous. You guys don't really need to worry about this part, because that's notation that you guys wouldn't really deal with. It's fine. This thing is just kind of explaining to you what the choose is. As it says, this is for the binomial coefficients. I should also point out the word coefficient just means the number in front of the, so if it was 4x to the power of 5, the 4 here is the coefficient, x is the variable, the 5 is the power. You know how it is. So and you notice that here's a term, 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 and in all of them the coefficient, the number at the front, is given by the n choose whatever relevant number it is, and they just give you a formula for n choose or. Now you can write it this way or this way. I've never really seen anyone write it that way. You can if you want, I'm not going to judge you, but the formula for it is this, basically. Now you have the calculator, you can just do it for this question anyway. For part 2, I know there's an n involved in one of them, so I'm going to have to do that formula in the second one, but for the first one we can just use the calculator and it'll be fine. So the way binomial expansion or the binomial theorem works, and I kind of need to, I'm not going to try go too deep into it when I'm answering the questions, but this, as I said, isn't one that the teachers would have done, which is really, and it's not really one I would have done, which is. But this basically just says that the first term, so I could take this, I could write the bracket out 7 times, and I could multiply it all out, but that would take me days. So instead, I'm just going to, this tells us that the answer would end up being, the coefficient would be n choose 0. Right, and then here it would be x to the power of n. Now I haven't actually discussed what n and x are in this scenario. The x is the first in the bracket, so for us that's going to be x. Y is the second guy, so for us that's going to be y. And n is the power, so for us that's going to be n. So for me, I know my first term is going to be 7 choose 0. X to the power of n would be 2x to the power of 7. And the y doesn't exist in the first term. So the 1 over x for me is not going to show up in the first term at all. That's the first term set up, right? Then for the second term, it would be 7 choose 1. And I would do 2 to the power of x to the power of n minus 1. But for me, that's going to be 7 minus 1, so it would just be to the power of 6. And then the y, I was about to write the y, sorry. And then the y is 1 over x, but it doesn't. Now, it kind of, you notice here it says it doesn't have a power, but really it's the power of 1. You know what I mean? I'm just not going to write that. And then I'm going to do plus 7 choose 2. 2x, I'll explain a bit more. I'll try to shed a bit more light on this now in a second when I have a few to point at, basically. So this is the first, second, and third terms done with the pluses in between them. So in each case, as I said, as I mentioned before, they all have a coefficient of 7 choose something, depending on its position in the list. And you notice that each time we started with 2x, we started with the first thing inside of the bracket to the highest power, to the power of 7. and the y didn't exist. Then in the second one, the power on the first term, the 2x, decreased by 1, and the y appeared. Then the power on the x decreased by 2, and then the y went up to 2, right? So each time you go across, the power on the x term decreases by 1, and the power on the y term increases by 1. So we start with 7 on the x, the y not existing, and we're hopefully going to end at the very end with 1, that the x doesn't exist, but the y does have a power of 7. Now, in this question, you did not need to do all this out, but because you guys are just so uncomfortable with this, I'm going to do them all out, so that even though you're not going to do it, I wouldn't advise you necessarily doing it. Well, you can if you want, like, there's nothing wrong with it. But I just want you guys to see what it would look like, and where we're going to kind of decipher how we're going to get the answers from that, because I know it might be a bit tricky to kind of jump from just the theory to how to take the answer out without being able to see everything that's being done. Hopefully it's not too messy. That's just wrong though, obviously, because the power on the x term needs to decrease each time, and the past one was a 3, so this one's going to be a 2. The 1 over x though, the y value, if you get me, has to increase, so it's going to be a 5 this time. 7 choose 6, and this would be 2x to the power of 1, 1 over x to the power of 6. And then the last one, as we're kind of predicting, we want the coefficient to be 7, choose 7, because we can't go any further. We couldn't do 7, choose 8, so I know automatically this is going to be my last one. But we can kind of tell, because you notice if the power on the 2x decreased anymore, it just won't exist, because it would be 2x to the power of 0, which isn't a thing. So we're just left with 1 over x, but that power increases, so that would go up to a 7. So those are our 8 terms that we would get if we had multiplied out the bracket originally 7 times. Now, we still need to kind of tidy it up a bit, because each 7 choose nonsense thing you're going to do on your calculator, and that'll solve that out. Again, I wouldn't normally go into this, but I'm going to, because it's not done a lot in school or for me, right? I don't do it, which is a lot. And I drew the line just because it's going to get messy, because as you can see, there's already a lot of things. 7 choose 0 is 1. Now, 2x to the power of 7, that implies both the 2 and the 7 is to the power, or the x is to the power of 7. It's the whole first entity is put to the power of 7, not just the x. A lot of people just wrote 2 and then x to the power of 7. Problem solved. But it's actually, we have to put the 2 to the power of 7 and the x to the power of 7. So it's going to be 1 multiplied by 2 to the power of 7. Hang on, I know this. 1664, 128, I think. That might be wrong. I just don't really care, because the answer doesn't, it doesn't come into fact. It's not a factor. 7 choose 1 is 7, I think. 2 to the power of 6 is 64. And then x to the power of 6. Now this one still has a 1 over x. We'll talk about that. 7 choose 2 to 21. And then this would be 32. X to the 5. 1 over x. Now, here's the dealio. That's 1 over x squared. But if we think about it, and I'm going to do it on the side here. If you have this to the power of 2, that means it's going to be 1 over x multiplied by itself twice. And if we're multiplying fractions, we do top by top, bottom by bottom. So there'll be 1 by 1 on top, which is 1, x by x on the bottom, which is x squared. So I just know I can change that. Now, you don't need to write this every time on the right if you don't want to, but it's kind of a handy way to know what you're doing. But I know then I can just rewrite that as 1 over x squared, where the squared is on the x only, not on the top thing. And that kind of makes sense, because an alternative way of doing it would be, if you're squaring a fraction or putting any fraction to a power, you can just put the power on the top and the bottom of the fraction separately, but 1 to the power of anything is just always going to be 1. So that's just another way of doing that. And I'm going to do that with all the rest of them. Hopefully you're okay with that. 7 choose 3 is going to be 35. It's going to be 16, x to the power of 4. 1 over x cubed. And again, I'm just putting the 3 on the x on the bottom. This will also be a 35. This will be an 8 x cubed. So another thing with the choose, and I'm not sure if people are aware, this is that they loop around. So the 35 is twice. This next one is going to be 21 again. But this will be 2x squared. No, it won't. It'll be 4x squared. I lied. 1 over x to the power of 5. And this one will be a 7 again, because it loops. This will be the 2x, and this will be 1 over x to the power of 6. And then this will be 1 multiplied by just 1 over x to the power of 7. Now, that's all of it done out again. Now, again, you could still multiply them all out to tidy it up. I just don't have to write it all out again because these always take longer than I imagine. I always spend too long doing things that I don't need to be doing. So at this point, what I'm going to do is, I think you guys would all be comfortable with proceeding yourself at this point. So I'm going to hopefully just be able to skip to the bit that I wanted to skip to earlier when I said that I wouldn't normally write all of this out, because in the question they only asked for the coefficient that would have a 1 over x cubed in it. Now, that means we're going to look for, there are 8 terms here. 1, 2, 3, 4, 5, 6, 7, 8. We're going to look for the one that has to the power, or it has a 1 over x cubed in it. Sometimes there's more than one, but in this case there's only one. And the problem is a lot of people assumed it was this one because this has 1 over x cubed in it. Happy days. No happy days. Misery for everybody, because there's also an x to the power of 4 which is not underneath a fraction. So if we were to take that one, let's just say, let's say we took, I'll get rid of that. Let's say we took this one as an aside, and I said it was 35 multiplied by 16 x to the power of 4 multiplied by 1 over x cubed. 35 by 16 is going to be 560, I think. But we're still left with 560 x to the power of 4. The 560 might be wrong. It's just not relevant, so I don't care. Now, do you remember, if you're going to multiply fractions, you would do top by top, bottom by bottom. But Graham, this isn't a fraction. Yes, it is, you loser. You can make anything into a fraction by slapping it over a 1. And then you do top by top, bottom by bottom. And then it would be 560 x to the power of 4. Ew. After calling you a loser, I'm after fucking up my 4, something fierce. X to the power of 4 over x to the power of 3. But if we use our indices rules, that just turns into 560x, because there was 4 and a 3, and they break down. If there's 4 x to the power of 4 on top, x to the power of 3 on the bottom, you minus the powers to figure out what's left behind. So this term isn't the one we want, because even though it looks like it has a 1 over x cubed at the moment, its final result won't. So that's not the one we want. So you could go through all of them and just kind of figure out how that would work. And again, you don't really need the numbers. Like, that's why I was saying the 560 is irrelevant, to figure out which one we're looking for. Because here I just know there'll be an x to the 5 that's not under a fraction, and a 1 over x squared. So I could slap that over 1 and do the x to the power 5 over x squared, but I just know that's going to be x cubed eventually, because I'll have an x5 on top and an x2 on the bottom, and they'd eventually cancel out. But that's not what we want either. And that's even like seemingly going in the wrong direction, because you notice we'd have x6 on the top and x on the bottom, which would be x5. Don't want this. It is just x7, that's just rude. This one would be an x3 on top and x4 on the bottom, but that would result in a 1 over x, because it would have been x cubed on top, x to the 4 on bottom. No bueno, we don't want. It's gone, it's dead to us. This is the one we actually want though, because you'll notice if you ended up with an x squared multiplied by 1 over x to the power of 5, that would eventually end up with an x squared over x to the power of 5. Which would be 1 over x cubed. I should highlight, I suppose, just in case people are confused, how I'm getting the x cubed. I'm using the rule in your log tables that says if you have a to the power of p over a to the power of q, it's like the second one down on the left hand column on page 21 of your log tables, right? It has, you can change that to a to the power of p minus q. So what I did here was I said, well, that's p, that's q. Oh, well, now this is going to be an issue, because if I use this rule, it should tell me to do a to the minus 3. But a to the minus 3 is the same as 1 over a to the power of 3. And that's using another rule in your log tables, bizarrely. That's in the same list, but I can't remember. That one's like the 6th one or something, or the 5th one. I can't remember where that one is. If it says it has a minus power, you can slap it under a fraction if you just change the power to not be a minus anymore. So I just kind of skipped all of that shit, and I just said that one would be 1 over x cubed. That one might be a bit of a sticking point for people, but I'm weirdly gonna hope not. That you've all understood how I got 1 over x cubed in the first place, even if you didn't like the blue bit that I did, but you kind of understood it otherwise, like algebra wise, instead of rule wise. The summary of the whole thing is, though, that that's the one that we want. This is the term that we want. We don't want this one because it has an x here and an x to the power of 6. So the result of that would be 1 over x to the 5. So we don't want that. And this one is just 1 over x to the 7. Not what we want either, right? So this is the one we're going to hone in on. And in the question, I know I don't have the words written up in here, but the question just said, what's the coefficient of that? What's the coefficient of the term that has a 1 over x cubed in the answer? And the coefficient is just the number at the front, so I'm going to look at the 21 multiplied by 4 that I kind of ignored up until now. That would be 84, and that is your final answer for this question. That is the coefficient of the 1 over x cubed term, because it's the number that would have the x cubed with it. I will say, some people might have done algebra where where the whole term, the whole sixth term, would have turned into 84 over x cubed, which is the same thing. It's just that you'd have to like deconstruct it into this, which is, you're allowed to do that. Because if I had slapped that over 1 and done top by top, bottom by bottom, I would have gotten back to the 84 over x cubed, so it's fine to go this way as well. I could go this way, but I can also go this way, that's fine. Whoops. So yeah, 84 is the answer to part B there. It was kind of a nasty one, but reasonable at the same time. Do you know what I mean? Reasonable for a leaving cert. It's not going to be, it's not like how dare they. The next one was, I would imagine, it's going to be quicker, I think, writing wise, but messier for explanation wise. So, what are we on? Part 2 here. Again, if there's an issue, if I'm not doing this clearly, if there's something I'm not thinking that people are making a mistake of, just let me know, because it's probably like for the best that I know the things that I'm just glossing over. Do you know what I mean? Because there might be things that are actually better off that if I changed how I said them. So by all means, let me know. I do reserve the right to, if you guys say, Graham, I think you should say this instead, I do reserve the right to kind of tell you to fuck off, and that's not true. But that's that's just because I'll take your criticism on board, but at a certain point I'll actually just go, do you know what, I've done this a long time, and if it's something that I'm like, no, that wouldn't work, actually, I don't think that would be conducive at all, I probably won't. I won't tell you to fuck off unless you're specific people, but we'll see. Hold on, I'm just gonna spinning my wheels here while I'm trying to read the question. So, in the binomial expansion of this shit now, in ascending powers of x, in ascending powers of x, that doesn't really matter, but I don't think that, I just don't know what I said. The coefficient of x squared is 7 over 16. Given that n is the positive integer, find the value of n. So, oh yeah, I didn't write anything though. They basically said the coefficient of the x squared term. In the past, when they asked us what was the coefficient of 1 over x cubed, here they're saying the coefficient of x squared is 7 over 16. So what would n have to be in order for this to make sense? And basically what they're saying is, if you change the different values for n, you're going to have a different binomial expansion of this each time. However, for a certain value of n, in the binomial expansion, the x squared will have a 7 over 16 as its coefficient. What value of n does that work for? And our job is to figure that out. Now, you could just keep guessing values of n and doing the binomial expansion for that, but no, we're not doing that. Instead, what we're going to do is we're going to do the binomial expansion for n and then kind of figure that out. Now, the problem with doing that, though, as I said, this is going to be more theory than writing. The problem with doing the binomial expansion for n is in the above one, it was to the power of 7 and we had 8 terms. This is the power of n, so we're going to have n plus 1 terms, but we don't know how many that is, so there's no point actually trying to write out all of the terms for the binomial expansion, just because we don't know how many there are. Now, if you want to, you could do the first few, and I might actually do that. That might work out better. So if we follow the binomial expansion again, the first one is just going to be n choose 0. Before, again, I could do 7 choose 0, but we don't know what n is this time. And the first one would be to the power of n, and the second one doesn't exist. And we do plus n choose 1, do the first one to the power of n minus 1, and the second one to the power of 1. Because as we said, the power on the first one decreases each time, so it went from n to n minus 1. I wrote it too, ignore me. So the power on the first one decreases each time, so it went from n to n minus 1, because n minus 1 is the next number down from n. And the power on the x over n increased from 0 to 1. Then I would do n choose 2. And then the power on this one would decrease again, so it would be n minus 2. And the power on this one would increase again, so this would be squared. And then we could keep going if we wanted to. And the power just keep decreasing to n minus 3. Power would keep increasing here to 3. But the problem is you'd have to, like, you don't know when the last term exists. Now, I know the last term should look like n choose n with x over n to the power of n, because the first term would have disappeared and the second number would have the full amount as its power. But the dot 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 just signify that we don't know how many terms there's going to be, and there's no point in me just keeping writing them. Particularly, not only because we don't know how many there are, but particularly because we wanted to talk about when the coefficient or the term has an x squared in it. And you notice this first guy here doesn't have an x in it, so he's not playing any part in contributing to the x squared whatsoever. It's only the second term that's going to contribute to the x squared. This guy, this whole term, there's no x involved anyway, so it's not him. This one, the only x that exists here is here, but that still has to be put to the power of 1. So that would give us an x to the power of 1, so that's not relevant either, so he's gone. This one, there's no x, again, at the start. There is one here, and that has to be put to the power of 2, which would give us the x squared that we want. So that is actually the one that we want to use, because that is the one, if I do it out, I will have an x squared. In the exam, if you weren't sure, you could just multiply out the brackets just to make sure, because maybe I can see further down the line how this is going to work than you guys can. Maybe that's what the issue is here, and I'm just not aware of that. So by all means, now n choose 2, I'm going to talk about in a second, but I'm going to just multiply out the other things just to tidy it up a bit first, because at the minute there's a lot going on and I feel like that's going to fry your brains. Yeah, and I'm just kind of ignoring all of these, right? There's no need for them. We only care about this because none of these would have an x to the power of 2 involved. They'd be an x to the power of 3, an x to the power of 4, so on and so forth. And that's what they meant when they said ascending powers, but there's no like they didn't need to say that. So as I said earlier, if there's a power on a fraction, you can just attribute it to the top and the bottom, and that's all I did. And you notice that does confirm the x squared. 1 to the power of n minus 2. Now we don't know what n is, but no matter what we put 1 to the power of, 1 to the power of 2, 1 to the power of 6, 1 to the power of 17, 1 to the power of, pi, 1 to the power of 6 over 92. It doesn't really matter. 1 to the power of anything is just going to be 1. So that's nice. So basically, this guy here, it doesn't matter what n is, it's just going to effectively turn into a multiplied by 1. And if that's the case, I don't care about it, because multiplying by 1, you know, it's just, yeah, it doesn't change anything. So I'm just going to ignore it, because, you know, multiplying by 1 is nothing. Now, the n over 2, we're going to have to talk about that. So earlier I said, oh, the formula up here for n choose or is here, but I'm going to ignore it for the time being, but I'm going to write it out here, because it is super relevant. So for this guy, I have to write it out because we can't write it in the calculator, because the calculator can't do n. So we're going to have to just actually write it out like so. And if you look back up to the formula, I've literally just filled in the n in the n position and the 2 in the or position. That's all. This would still be x squared over n squared, just carrying him down. He's just the same guy. Now, if you guys recall factorial, so n factorial would mean n multiplied by everything smaller than it. And the number smaller than n would be n minus 1. Number smaller than that would be n minus 2. The number smaller than that would be n minus 3. Because each time you're just minusing an extra 1 from it. And that would go all the way until they got 1. But again, we don't know what n is, so we don't know how many terms there are. So we're going to do the dot, dot, dot. However, n minus 2 factorial would be n minus 2 multiplied by, now I wrote the wrong sign there, obviously. It should be n minus 2 multiplied by the number smaller than that. But if a number smaller than n minus 2, again, if you take away 1 from it, would be n minus 3. And that would go on and on again until you get down to 1. But you'll notice that n minus 2 all the way down to 1 exists here as well. So if we were to put them as a fraction, this would cancel with this. And all we'd be left with is the n multiplied by n minus 1 on top. That's all that's going to happen. I'm going to write it out. I was debating about not doing it. I will write it out over here. So instead of n factorial on the top of this fraction, we'd have n multiplied by n minus 1 multiplied by n minus 2. All that goodness. Yeah, I'll do one more. Yeah, sorry. Some moments there's more writing than talking necessary. So we're just going to have to sit here for a second. Now on the bottom, 2 factorial is just 2 anyway, so that's fine. I'll leave it as 2 factorial for the moment just so I can write it easier. 2 factorial. But then n minus 2 would be n minus 2 multiplied by n minus 3. Oh my god. N minus 3. All the way down to 1. And as we said, they would cancel. The n minus 2 cancels the n minus 2. The n minus 3 cancels the n minus 3. The 1 cancels with the 1. All the rest cancel with all the rest. Yeah. And then we still have this other fraction carried down the whole time. The x squared multiplied by m squared, x squared divided by n squared. People don't carry those things down, they often forget them, so you just got to keep on your toes about that. So we're left with n multiplied by n minus 1 on top of the fraction, 2 factorial on the bottom, multiplied by x squared over n squared. And that turns into n squared minus n over 2 multiplied by x squared over n squared. Now, a lot of people, and I was kind of happy to see this at the same time as being upset by this. Not upset, but just kind of like, oh, I'm going to have to, like, they've done something right, but I'm going to have to tell them they're wrong. Because people automatically multiplied the brackets together because they said, I know how to multiply fractions top by top, bottom by bottom. It's trickier if you do that, because if you recall, they want the coefficient of x squared. And if you multiply the coefficient in, if you multiply the x squared in, you get n squared x squared minus nx squared. So now there's 2x squared, so we kind of don't want that. We don't want that result. Instead, we want to kind of just leave the x unattached, if you get what I mean. And I know that's tricky to see on the day when you're like doing your maths exam. I understand that, but we kind of want to leave it like that so that we have an x squared, so we know what the coefficient would be. Excuse me. And on the bottom we'd have 2n squared. Now, I can cancel an n out of all of those. That might be trickier for you to see. Maybe you do need to multiply it out so you can see you can take out the n. You might do. Maybe you'd need to multiply at the top so you can take out the n. But then you'd have to go backwards and take out what's common, which is an x squared. Maybe that's what you'd need to do. The way I would do it though is I'd cancel them out and I'd be left with n minus 1 in a bracket, x squared over 2n. Yeah, what I'm saying is if you can't see what I just did with the cancelling there, you might need to multiply it out into the gross bit that I said not to do just a second ago, and now I'm changing my mind, obviously. And now you might be able to see why I'm cancelling out an n from here, here, and here, because I can take an n out of all three of those, and I'd end up with nx squared minus x squared over 2n, and then taking out what's common on the top would leave you with an x squared n minus 1 over 2n, which is the same as what I have over here. So maybe you do need to do that to see it again. That might be another issue. Let me know. If you can't figure that out, let me know, because that is just something that's like annoyingly. I'm not sure how you guys would handle it. I might need you one of you to say to me, like, actually we wouldn't. A lot of us wouldn't get that straight away. But anyway, I'm gonna just move on with this for the time being because I don't know. I don't want to go too deep into it if you're all sitting there going like, yeah, no, that's fine, we get you. But this basically then, if you trail all the way back, is this term here. So all of this breaks down to all of this. Breaks down to this fraction that I have down here. Which is what we wanted, because again, we were looking for the thing with the x squared. For us, the x squared is here, and they said the coefficient is 7 over 16, and we said, uh-oh, bud, our coefficient was n minus 1 over 2n. Because again, the coefficient, now I might have been saying it's the number in front of the x squared, or the x to the power of n, or whatever it is, but don't forget, it could just be under it. Like, it's just kind of finagling the algebra around a bit. So the coefficient is what's with the x squared. I'll rephrase it now. Even though I won't say that in the future, that's kind of what the implication is. So I do apologize if obviously that's not clear, but that's what we meant when we say coefficient. Now we're going to put it equal to 7 over 16 because that's what they said they want the coefficient to be equal to. So that's why we're putting them. They're saying the coefficient it should be 7 over 16. We're saying this is our coefficient. We're saying, well, if they should be the same thing, what value of n should we use that would work for that? And all I'm going to do here is, now this is like a separate thing, just so you don't get confused. I'm going to multiply on both sides by 2n and 16. Multiply the whole line by both of the denominators, because the 16 cancels here and here, and the 2n cancels here and here. And then you're left with 16 multiplied by n minus 1, and 7 multiplied by 2n, which is 16n minus 16 equals 14n. Bring the 49 over, 16 over here. You get 2n equals 16. Should highlight. I brought the minus 16 over, made it a plus. I took the 14n over, made it a minus. Ew. Made it a minus. 16n, take away 14n is 2n. And then divide both sides by 2. Get n equals 8. And that is your final answer here. Because I said, what is the value of n that we would need here and here in order for the coefficient of the x squared term to be 7 over 16? And that's just what we're saying. Now, I'm going to take a quick break here just to make sure the recording's working okay, because I'd be devastated if it wasn't. Okay, it seems fine. I do apologize also. I realized that all of question 1 took me 35 minutes. It's unfortunately just how long I feel like it takes. Do you know what I mean? It's not, I'd obviously prefer to do it quicker, particularly because you fuckers are all TikTokified, or you need the stuff to be 3 seconds long or else your brain snaps. So I'm not trying to do it longer than it needs to be. Hopefully you all understand that I'm trying not to do it. Now, it says find the range of values of x for which this fraction is greater than or equal to 5. Now, it says in the question x is an element of the real numbers. Not hugely important. And it says x cannot be equal to 1.5. Now, what some of my students are starting to do is they're starting to realize that if they say x can't be equal to this number, that's probably one of the answers. So, basically, just to, because I know people still don't really get inequalities, the whole thing that this question is basically asking you is, it's saying what values of x could you sub in into this fraction so that the final result will be greater than 5? And there's going to be more than one. Now, I can't think of any just looking straight at it. If you gave me a few moments, I would, but I'd just be wasting more time. So basically, they're saying what different numbers could you sub in here so that the answer would be bigger than 5? And there's going to be more than one or two. If it had said equals to 5, then there would have only been 2 answers. But because it says greater than 5, or sometimes it might say less than 5, that means there's multiple answers. But the trick is, if you have a rational inequalities, a crocodile symbol is inequalities, just in case we run into that, and then rational means a fraction, you have to multiply both sides by 2x minus 3 squared. The denominator, the thing on the bottom of the fraction, squared. And then what will inevitably happen is this 2x minus 3 cancels with one of the 2x minus 3s that we get from squaring this out, because squaring means that bracket appears twice. So just by cancelling it there, one of them fucks off. So we'll be left with 2x minus 3 without the squared, but we'd also be left with the 3x minus 1 without the denominator. We're going to say 5, 2x minus 3 squared. Now, what's this? 6x squared minus 11x plus 3. This is where I always try to do things faster and end up fucking it up. That's going to be 20x squared. And that's going to be minus 60x. Lie to your face, 30. No, 60. 3 by 2. Yeah, 60. Yep. Plus 45. At this point, I'll notice that it kind of looks like a quadratic on either side. So I'm going to just move everything over to that side so that it is a singular quadratic. As in, there's nothing left on this side, because the 6x squared would become a minus 6x squared over here. So that would be 20x squared minus 6x squared, 14. This would be minus 60x plus 11x, so it's going to be minus 49x. It's going to be 45 minus 3, so it's going to be plus 42. And it annoys me that's I didn't spot that all these numbers are divisible by 7. One of you fucking nerds did. You divide all these by 7. You don't have to do that step. That's just to make the numbers smaller. So don't think you needed to do that. Either way, if you've just done the minus b even in this line or in this line, you'll get your answers. But I need to highlight that when you're doing the minus b, when you're getting your answers, even if you use the brackets, which I wouldn't advise you to do, but I just know some of you are going to try to do it. What we're going to do is we're going to pretend like that question kind of stalled for a second, and we're doing the exact same question, but just with an equals instead. Just with an equals. And when you do your minus b, I think, if I remember correctly, your two numbers are x equals 2 and x equals 3 over 2, which I will point out is 1.5, and that's probably why they mentioned that number up there. I'm probably going to go with the 3 over 2, but I just wanted to mention that that is the same as 1.5. So when you get your minus b, those are your two answers. Now, a lot of people will just like say, they're my answers, coolaboola. But remember I said when there's a crocodile in the question, it's going to be multiple answers. And it's because we're now going to go back to this line. The one that I said we're going to put a stall on it. And we know that the graph of that, because it's a positive x squared, the graph of that should be a u shape. Like so. I don't like that, so I'm drawing it again. Like so. That's so much worse. One more time. I'm going to stick with it no matter what it is, because it doesn't actually matter. And we're just going to draw the x-axis. The amount of people that draw the y-axis, but it's not necessary. It's if anything, it just confuses the issue. So there's our x-axis, and there are our two roots, as in where the function crosses the x-axis. These are our roots. That's what the minus b formula gives you. It gives you the roots. The smaller number, though, has to always be on the left, and the bigger number on the right. And 3 over 2 is smaller than 2. If you're unsure, put them both into your calculator, get them as decimals, and just see which decimal is bigger. Then we need to look at the question. The question, and when I say the question, I mean the line that we put a pin in. The question is saying, when is the quadratic smaller than 0? And what that's basically asking you, that line there, is asking you, when is the y value on the graph less than 0? So this line here is basically saying, when is the quadratic less than 0? When is the y value less than 0? When is the graph underneath the x-axis? Because you'll notice these are all the points on this curve where the y value would be a minus. Hence, they would all be less than 0. That's what it's asking. I think I did a separate video on these as well, so maybe I shouldn't go too deeply into this. Just look at that video instead. Yeah. So basically this is saying, when is the graph less than 0? We're going to say, as long as you stay in here. Unfortunately, you can't just highlight that part of the graph. You can't just put dots on it like I did, because the examiner needs to see you writing maths on it. You can't just point to it either, because, you know, that would be stupid. The examiner can't see that. So what we have to do is we have to write it in maths terms, and we're going to say, as long as you stick on the x-axis here to here, you'll be fine. I know I overlapped on the left-hand side. You can, hopefully he's going to ignore that. As long as you stay on the x-axis in between the 2 and the 3 over 2, you should be fine. So what I'm going to do is I'm going to write 3 over 2, I'm going to write the x, I'm going to write the 2. Which number is bigger? The 2. So the crocodiles are both heading that way in like a conga fashion. But in the question, there was a little equals, a little line underneath the crocodile, so we have to put in a little line under the crocodile. However, we can't put one in onto 3 over 2 because it said in the original question that you can't have it be equals to 3 over 2. So we can do it here because x can be equal to 2, and this would all still make sense, the original question, before I scribbled all over it. But this would not if I put the little equals there. That's no good. You need to leave your answer like I have it now. But that's the answer to that one. If, now I'm going to do this in a weird color pen so you know that it's not actually the answer, right? If the question had said the crocodile the other way around, it would have been, when is it above 0, which would be obviously... Now, obviously, this isn't working out because they all look similar. Those dots look similar to the orange ones, but trust me, they're different because I said so. That's what it'd be asking you. It'd be saying, when would the y values be positive or above the x-axis? And those are two different branches. We have this one up here. We have this one up here. Two separate guys on the graph. So they need to be two separate parts of maths. So down here, I'd say, as long as you stay to the right of 2 on the x-axis, you're good. So and if you think about it, all the numbers on the x-axis to the right of 2 are bigger than 2. So I'd say as long as x is bigger than 2, you're fine, because you're going to end up having to go over here and then go up. Or as long as you go to the left of minus, or the left of 3 over 2. But the numbers to the left of 3 over 2 would all be smaller than 3 over 2. So instead of saying the numbers on the x-axis to the left of 3 over 2, I said x less than 3 over 2. Because it is... hold on, I've done something arseways, haven't I? No, I lied. I'm perfect, as always. So, Yeah, x has to be less than 3 over 2 because all the numbers on the x-axis to this side of 3 over 2 would be smaller than it. So when we write x, we're kind of saying the x-axis. We're saying the x-axis to the left of 3 over 2, kind of. Because that would also mean you'd have to go up to get to the curve, and so it would have a positive y value. But I need to stress that last bit I've done with the rainbow pen is not actually the answer for this question. It's just a hypothetical if it does come up written that way. Okay, if the crocodile was the other way around, that can happen. Again, I've done a video on inequalities. You can look at that if you want to, because I know I'm just going to keep talking about it. So I'll move on. B is probably one that more people were stuck on, to be honest, because it has logs in it, and people just do not, for the love of God, like logs. Log base 10 x squared. You kind of want to go to page 21 of your log tables. That should be a 3. How dare I? 3x minus 9 equals 0. Now the thing about logs is, again, it's on the top right of page 21. I will get it, hang on. Again, there we go. Didn't mean to scare you. But the top right of page 21 of your log tables tells you what to do if you have a log that you can't move forward with, or if you have a power that you can't move forward with. Now the power bit I'll come to later in one of the long questions. I think there was the one with the bacteria you needed to use it. I think. Don't take my word on that until I actually do it. But for this one, we definitely need to use it because we're stuck with a log. You can't type that into the calculator because of the x's. So we kind of have a situation like this that we're stuck on. So what I'm going to do is I'm going to identify my a, x, and y. Here's my a, here's my y, here's my x. So I'm now going to write it out this format, but I'm going to just use my values of a, x, and y. I'm going to have 10 to the power of 0 equals all this shit. Because that's just what logs are. Again, logs, don't forget, are just saying, what would I have to put 10 to the power of to get this whole bracket as an answer? 0. That's what it's saying. You'd have to put 10 to the power of 0 to get this bracket as an answer. And you notice that's what I have from just following the rules. Even if you don't understand it, if you follow the rules, it will just tell you. Now, some people did this, but the issue they forgot was anything to the power of 0 is 1, not 0. So 10 to the power of 0 is actually 1. And people lost a fair bit of marks. I thought it was a bit harsh, to be honest with you. And you hike him over, make him a minus. You get this. And then you would do your brackets. Yes, and you'd get x is equal to 5 and x is equal to minus 2. Doesn't sound right. I think it is. Though. Alright, I think those are the two answers. I think that's literally the end of the question. Now with logs, though, you always need to do one last thing, where you go back to the original and think, if I subbed in, let's say x equals 5, everywhere there's an x, does that equal a minus? Because you can't have a minus inside of a log, right? Inside of the big part of a log, anyway. Well, unless there's we won't get into it, because in the leaving cert, no. So if I sub in 5 here, I get 5 squared minus 3 times 5 minus 9, which would be 1, which is fine. It's not a minus, that's chill. If I subbed in minus 2, I would get minus 2 squared minus 3 times minus 2, take away 9. That would be also 1, so that's actually fine as well. So they're both fine. Sometimes, let's say we've done it and we got a minus 1, we'd have to strike that off. But that's not the case. Those are your two answers. I think that's it. I think that was fairly... You guys might be upset when you see things like that, though. I'm always afraid you guys are going to be like, is that all the maths we have to do? Like, it's painfully easy when you show us. But obviously on the day, we wouldn't have been able to do that. Just because, you know, you aren't doing maths all day, every day like I am. You have other subjects to be doing. I understand this. A social life, as we say. So... With logs, there's always two kind of different ways that logs in the short questions can be kind of used. They can either give you a log equals a number kind of situation, like we had in the last one, in which case you can employ the top right of page 21, and that goes away in no time then, just becomes algebra. Or you can end up with a log equals log situation, in which case you can cancel both of them out. Now, the problem here is, this is, even though it looks like the second version that I said, whoops. So I said that first version is log equals to number, that's what we had up here, and the second one is log equals to a log. And you might initially think, well, Graham, that's what you have here because we have a log equals log, but because of the 1 minus, we don't. If that wasn't there, then we could just do the log equals log version, and that occurs where you just get rid of both of the logs, and you just get left with, oh, x minus 2 equals x minus 6, perfect. We cannot do that though because of the 1 minus at the start. So that is all just immediately out the window for this question. But this is what I have an issue with the mock questions. I don't think they'd have done this because both of these work out to be a log equals a number question. And I don't think they would have done both of them at the same time in the exam. Maybe I'm wrong in the actual leaving cert. Maybe I'm wrong. But what I'm going to do is I'm just going to do what we normally do. We have this guy over here is a minus, so I'm going to move him over to this side of the equals and make him a plus instead. Because then we're going to have log 5x minus 2. Again, more writing than I would kind of hope, and that's a plus. Log base 5 of x minus 6 equals 1. The reason why I did that is because we're slowly getting back towards the purple circle up here where we just have log equals a number. Now, there are 2 logs, so that's problematic. If you go to page 21, the second column, the first one tells you that if you're adding 2 logs that have the same base, you can combine them if you multiply their innards. I don't know how that's going to sound. Does that sound like gory? Is that I don't know. So it's just a weird thing to say, maybe? I don't know. My maths brain is kind of on at the moment, so I'm not really thinking what I'm saying, to be totally honest with you. Oh, look, it's the same question as above, basically, just all the numbers are changed. This is why I don't think they do it in a real leaving cert, because it's too similar. It breaks down to being too similar. Again, you'd say this is my A, this is my Y, this is my X, and then again, I'm just going to translate it to the other variation, the orange circle, because then we'd have 5 to the power of 1 is equal to x squared minus 8x plus 12. 5 to the power of 1 is 5, though. And then we'd have this. You see, like, I'm kind of assuming you guys, if you were all right with the last question, this one would be fine as well, because this would be plus 7. And then we get x equals 7 and x equals 1 as our answers. However, like I said earlier, we need to go back and check that they actually work. And you notice that the 7 would work fine for both of the brackets. Here it would be fine, here it would be fine. The 1 wouldn't, though, because you notice it doesn't fit into either of them without giving you a minus inside of the brackets. But instead of having to actually look at that, you could just say, oh, they told me x has to be greater than 6. So, person non grata, or whatever they say in the Latin. And our answer is just x equals 7. And that's all of question 2 done. They gave you a massive amount of room for part C on the actual exam. That is just what they'll do. They're kind of afraid of not giving you enough space, but also they're afraid that you guys are going to criticize them and say, yeah, they're afraid, oh, you guys didn't give us enough space. It's better for there to be too much space than too little, right? Now, I forgot to just write question 3. I'm all over the place, I know. 7 or Z. Jesus, lads, I'm just not feeling well today, right? So just excuse those things. Jesus Christ, you guys know I'm better than that normally. Well, am I? That's the question. Z2, not 7, 2. Z2 is equal to Z1 squared. Gross. Do I have all that down right? Because I said it arseways, so I just want to make sure I took it down right. Show that Z2 is equal to this garbage. Well, Z2 is just equal to Z1 squared, so I'm just going to square out Z1. Yeah, just write it out again. That's all squaring is. I think we're all aware of that. I squared is always equal to minus 1, don't forget. So that's going to be a quarter. That's going to be minus root 3 over 2i. And that's going to be plus 3 over 4 I squared. But then the I squared turns into a minus 1. So that goes away. And this changes to a minus. You can always rewind it or stop it if I've done something crazy and you don't like it. So we have a quarter minus 3 over 4, which is, I promise you, put that in the calculator, is minus a half, minus root 3 over 2i. And that's what it says in the question. It says, show that Z2 is equal to that. Again, I can skip steps. I can kind of see certain things right now. The problem is I say that, and in trying to skip certain steps, I will end up fucking something up. I guarantee you, right? But don't feel bad if you have more writing or if it took you longer to actually do that. Do you know what I mean? Some of you might have split the brackets, some of you might have done the loops, some of you might have more terms, some of you had to do another line for the I squared thing. All perfectly fine. There's nothing wrong with doing that. So don't be beating yourself up about stupid shit. Do you know what I mean? If there's an issue with something, I will try to say it. Now, obviously, I might miss stuff, but you don't have to write it exactly the same way as me, is all I'm trying to say. Now, they're saying show that this would equal to this. Now, here's a bit of controversy that I don't know if people are going to agree with me. Some people subbed in the Z1 and the Z2 here, and then just had a massive pair of brackets to multiply out, which is fine. I would prefer to multiply it out now while it's just like, I don't mean simple letters, but there's not like masses upon masses of stuff. So I'm just going to multiply these brackets together now. I would get x squared minus xz2y minus xz1y plus z1 z2y squared. And now I'm going to sub in for the x, or for the z1 and the z2 everywhere. So I'm going to have x squared minus x, z2 is minus a half, minus root 3. Root 3 over 2. We're just going to get past that. We're not going to all emotionally cry about that like I am doing internally. We're all just going to get over it. Just leave it for therapists to sort out. But some of you, basically what I was trying to say is, though, some of you would have tried to sub in the Z1 and the Z2 initially and then multiplied out those massive yolks. I think it's better to kind of get the multiplying done and then do the subbing in. Although looking at it now, I forgot the I on here just to say. Looking at it now, it might be worse this way. But that's the look of the draw. Normally it's better to do it my way. This might just be one of the unfortunate situations where I'm mistaken, which is a very rare situation, as we all know. I can hear you sneering through the fucking recording. It's crazy. X squared. Now, I have the x and the y on either side of the brackets. But basically, because multiplying doesn't matter what order you're doing in, I'm just going to kind of move the y here, just so it's easier. I'm just going to multiply everything by minus xy in one go. So, minus xy by minus a half would be plus xy over 2. Or a half xy. Which would you guys prefer? I feel like you guys prefer the number at the front. So, I would do xy over 2. Alternatively, you could do a half xy. That's also fine. And I might do it that way just because I think you guys would prefer it that way. Then we'd have plus root 3 over 2 xyi. Then we'd have minus, by minus is a plus, a half x. Oh, again, I'm going to throw the y at the front here, so it's xy. Then minus root 3 over 2 xyi. Now, oh my god, so I'm going to multiply these two brackets together first and then stick a y squared at the end. Hopefully these are all okay. I'm multiplying these two together and that's what's going to be in this new mega bracket. That's going to be a quarter. Oh, it was a fly. I thought there was something in my eye. That's going to be a quarter. That's going to be plus root 3 over 4i when I multiply this by this. That's what you get. You can do the fractions, on your calculator. I should point that out because I know the root bit is going to annoy people. The I you can't do on your calculator, so what you need to do is you need to do the numbers yourself and remember to do the I part yourself. When I multiply this by this, oh heavens, excuse me, we get minus root 3 over 2 over 4, over 4i. And then when we do the last one, it's a plus by minus, so it's going to be a minus. A root 3 by root 3 is a 3, a 2 by a 2 is a 4, I by an I is an I squared. Now, if you'll notice, whoop-de-doo, this plus root 3 over 4i and this minus root 3 over 4i cancel, because they're the same guy, but opposite sign. Because one of the things I didn't really make a note of is, you'll notice Z2 is the conjugate of Z1. So I was kind of hoping that was going to happen. I just wanted to make sure. Would it have been braver for me to have said it at the start? Yep. But yeah, you make a video doing the fucking mocks, then we'll see how you do. Yeah, we'll see. Also, you'll notice this cancels here. So that's kind of nice. And the reason why I kind of knew to look for that is because you'll notice in the answer that they want, no I exists. So I kind of knew all the I's had to disappear some way, some manner of speaking. So I just went to look at them and just kind of went, how would that go away? This would be x squared. These two are like terms, so I'm going to add them. So if we have a half of an xy over here and a half over here, that's like having a full xy combined. You could write plus 1 xy if you wanted to. I'm not gonna. Inside this bracket, I'll do it in a different color because it's getting messy. The I squared, I can change that to a plus then. A quarter plus 3/4 is 1. And again, I could write 1 y squared, or I could just write y squared. Basically, what I'm trying to tell you is if you fiddle around with that bracket, it all turns into a big fat 1. And oh look, we're left with the guy that we were asked to find. Problem solved. Again, I skipped a few lines. That one is notoriously messy, right? So you could... Like, I think they do that in even in the Leaving Cert. They deliberately make it messy to annoy you. So, even if you don't like the way I've done it, and you didn't like that I didn't like, you're like thinking it took me like 3 more steps to write it out. I would actually prefer if you guys did it that way, because you're not able to do. I'm kind of doing these questions to show you how to do them, and I'm hoping that if I show you the main layout, you guys will get the multiplying bit down yourself. You can do the multiplying, the nitty gritty parts yourself and focus on them. So I'm kind of hopefully just able to skip them so you guys can just see how the overall gist of it is, and then you can fill in the gaps kind of yourself. Do you know what I mean? So that's kind of what I'm doing. That's why I'm kind of my answers might look shorter than yours. I'm trying to just say, oh, you would multiply these two together, and then I'm going to skip that because I'm hoping you guys can do the multiplying part yourself. If not, if I'm skipping too much, again, let me know. But part B, I'll just move on to it anyway, says use De Moivre's to figure out this nonsense, this garbage heap. Now, using De Moivre's on a power of a fraction, don't forget, means we're going to have to add in the plus 360p or 2 pi p, depending on if you're doing degrees or radians. Also, you don't have to use p if you don't want to. That's just a letter I use. You can pick any letter you want. I just disagree that they teach you how to do it using n, but there's already an n in De Moivre's theorem. So for people who aren't very experienced with it, they might get confused as to which n is which. And that's just my logic. Now, this was annoying because the 2 being outside the bracket was just, okay, just like multiply it in. Okay, now power of a half. In order to do that, we're going to have to do polar form, right? First, before we even start. So we're going to draw a quick graph. Again, these diagrams do not mean anything. These are not for the marks. This is just for you. Let me just make sure no one's dying. No one's dying. That's fantastic news. Well, I'm sure there's somebody, but not that text. Oh, well, no one's texted. Yeah, no one would text me if they were in that situation, I'm sure. But 2 on the real, 2 minus 2 root 3 on the imaginary. You'll notice I did not measure them at all. It does not matter what if this measurement and this measurement are correct. We just care what quadrant we're going to be in. And we know for a fact that is the quadrant we're going to be in because it's plus 2 on the real minus on the imaginary, so we're going to be there. And we want to draw the line from the center out to the point. Why isn't that snapping? There we go. So we want that line, and we always have to draw a vertical line. None of this horizontal nonsense. Always vertical. And we have a triangle then. Perfect. And the triangle is always 90 degrees. Now, because we went across 2 on the real axis, that means this is 2 here, right? Because it's from here to here. And because we went down 2 root 3, this is going to be 2 root 3 as well. We do not include the minus because we only care about the length at that point. You can't have a minus length. The minus is just dictating that we went down as opposed to up on the y-axis there, that's all. Now, this is the or, and that's what we're going to have to find. We're going to use Pythagoras. Some of you nerds are just taught that if you want to do it, you would do like this kind of nonsense. Or is equal to a squared plus b squared and a square root. I'm just going to use Pythagoras because I'm not a fool. I'm not a fiend of a person. And I'm going to do like this. The one thing you do, no matter which way you do it in all seriousness, don't forget the 2 root 3 needs to be in a bracket. Or else your calculator will not do it correctly. And none of you guys know how to do that without the calculator. So God help us all. Opposite of squared is square root. So 4 is equal to or. And that means 4 is what our hypotenuse is going to be, which means 4 is what the radial is going to be in De Moivre's theorem. Isn't that fun? Isn't that quaint? Now, the angle we want the argument, the theta, is always this angle here. We always have to start from this and go counterclockwise. We can't find that directly, so instead we're going to find this one here. And I'm going to call that alpha. I don't like calling that theta because at the very end, if you end up with theta equals 30 or something, you go, oh, cool, 30. But you forget you have to do the actual orange bit instead. So I like to call it something different, and that's this angle here. And you notice the right angle triangle, we're looking for an angle, so we're getting SOHCAHTOA. However, it's always advised in this situation, even though you can use all of them, it's always advised to use tan, because tan does not involve the hypotenuse, which is the one that we found, and we don't want to use that in case we fucked up Pythagoras in some, terrible, terrible fashion. So we'd have tan of the angle, which is alpha, is equal to the opposite over the adjacent. This is the opposite, because it's opposite the angle. This is the adjacent. Some of your teachers will tell you to just do the imaginary over the real each time, which is what it always works out to be, but I have faith in you guys that you know trigonometry as well. So you do that, and then you would do tan inverse of that. Now the 2's would cancel, and you could write 2 root 3 over 2, but I was just trying to save time. But the amount of explaining I just did probably, got me back there. Now, sine, tan is sine over cos sine. Yeah, I think that's just 60. I think that's 60. But that's alpha. Just do that on your calculator, right? Because that's the one bit about this that might be wrong. Just don't make me please in a dark room search for a calculator. So what we would do now is we would then say, because we're in the fourth quadrant and the rule in the fourth quadrant is 360 minus the angle, we're going to say theta is equal to 360 minus 60, which is equal to 300. So that's what our argument is going to be. This is our modulus, this is our argument. Those are the fancy names for them, but in a certain leaving cert or two, they have mentioned like the actual fancy names and not anything else. So just in case that happens, I want you to be able to figure out. That's what theta looks like. Some of your teachers write it like a capital Q, like this kind of nonsense. Nah, we're not. Maybe that, I'm not going to berate them for it. They can do what they want. But in the way that it's written in the leaving cert looks more like my one than a capital Q, right? So just so you know, if you want to keep writing it as capital Q, that's fine once you recognize it when they give it to you. So, be written like this. But all of this was being put to the power of 1 over 2. Now, the 1 over 2, I know there's going to be 2 answers because of the number on the bottom of the fraction. Also, what question is this? 3? That's not. Okay, that's better than I thought. So power of 1 over 2 means there's going to be 2 answers. De Moivre's theorem says you have to put the power onto this guy and you have to multiply both of these by a half. However, we're not there yet because the power of a half means we have to change the setting. So we're going to change it to cos. But instead of 300, we're going to have 300 plus 360n. P, is the one I'm going to use. Plus I sine 300 plus 360n. P, power of a half. Yeah, and I want one more brackets, but I'll use square ones just so that it's easier to kind of tell what's going on. So that's the step. Don't forget, you technically we're supposed to put 360p in every time we do De Moivre's. However, it's only necessary to do it when the power is a fraction. If the power had been a whole number, it would just ignore these guys. But the power is a fraction, so you couldn't. Joke's on you. De Moivre's just says now put this to the power of a half and multiply both of these angles by a half. So if I multiply 300 plus 360 by a half, I will get 150 plus 180. Now, I've seen a lot of issues with that part, where people will multiply it by a half, but only multiply the 300 by a half. Some people did the whole thing as over a half, which isn't correct either, right? Because the sine isn't being halved, it's only the stuff inside of the angle. So that'd be 150 plus 360. I've also seen people, not 360, I've literally just done what I told you not to do. I've also seen people, they will just stick a half in front here, right, which is technically correct, that's technically fine, but if you write it into the calculator like that, it does it wrong. If you write it into the calculator like this, it thinks you want to do sine of a half, get an answer, and then multiply that answer into this bracket, which we don't want to do, right? So it's just easier in my mind multiply each of these numbers by a half yourself separately and just write them down like this. Let me just make sure I didn't fuck it up again. Yeah, no, I think we're chill. Now, 4 to the power of a half, you put that in the calculator, it's 2. And what we're going to do is, we're going to say p is equal to 0, what happens? And everywhere I see p, I'm going to put in a 0. Like so. I hope you're having fun, because I fucking am. Then this will be here. And then that's 2 multiplied by cos of 150 is minus root 3 over 2. Again, when you're doing this, you want to do cos of this bracket and just make sure that that's right. Plus, and then sine should be a half, so it should be plus a half I. But again, by all fucking means, check those. And you multiply 2 into the bracket, you get minus root 3 plus I. And then, see, that looks too clean for a Leavenworth answer, to be honest with you. I would have thought they'd have some sort of weird decimal in it. Then, because I knew there was 2 answers, I need to do a second one. But everywhere I see P, I'm going to sub in 1. They're going to make me look for a calculator, aren't they? They might be. I know what the answer should be, so let me just see if I can like backwards finagle it. I'm just lazy. That would be. No, that would be that's root 3 over 2, I think. Because it would be 30 in the fourth quadrant, which is the same as 30 in the first quadrant for cos. And then this is sine of 30 in the last quadrant, which is the opposite, so it'll be minus a half. I, you multiply 2 across, you get root 3 minus 1 I. So our 2 answers are here and here. Now, we don't have to go any further in this scenario because the power was a 2. So that meant that we only needed 2 answers and we have them. If you kind of were in doubt and kind of went, shit, I don't know if I have to go any further, if you do p equals 2, you should just get this first answer again, because the answers should loop around and just keep repeating, right? So if you want to just keep going until you get the same answer a second time and then go, okay, now I know for a fact I've finalized it and gotten all the answers, you can. I kind of feel good about my answers. I was going to get a calculator to check, but I kind of feel good because the answers should be, if there's only 2 answers, they should be conjugates of, or not conjugates, opposites of each other. So you know, that looks good. Now I'm just looking, the girl who sent me the things did it in radians. She got pi over 3, which is 60, so I feel valid. Do you know what I mean? I feel validated right there. Now, yeah, I probably should say, if you were using radians this whole time, I will just go back and write it all in like a translation kind of mode. If you had been using radians at the very start here, you would have gotten pi over 3. She is correct. Then here you would have done 2 pi minus pi over 3. Yeah, I think that's what you forgot to do, that's all. Then that would be 5 pi over 3, yep, instead of 300. And then everywhere there's a 300, there would be 5 pi over 3. So here, for example, it would be 5 pi over 3. But this would be 2 pi p. And then when you multiply this by a half, you get 5 pi over, you could do that in your calculator though. You get 5 pi over 6. And when you multiply this by a half, you get pi p. And then it should work out the same anyway, because you just put it in your calculator. Anyway, just make sure your calculator is in radians mode if you're going to do it in that weird, gross way of doing it. Question 4. Sorry again, I'm trying to speed it up without losing, without losing the actual integrity of the question. 4, part A, first principles. So fx equals 3x squared minus 8x minus 2. First principles, you need to get f of x plus h. So everywhere there's x, we're going to sub in x plus h instead. I should take this opportunity when it's a question that I feel like a lot of people, well, maybe not, maybe because then people will have skipped this actually. I'll say it in a second. Then we'd have this. Then we have 3x squared plus 6xh plus 3h squared minus 8x minus 8h minus 2. Then we have to do f of x plus h minus f of x, and that works out to be 3x squared plus 6xh plus 3. Now when you're doing this stage, when you're doing the minusing of the two, basically everything without a h should disappear is what's going to happen. Because you notice we're going to have minus all of f of x, which was 3x squared minus 8x minus 2. And then that's just going to cancel with this, because it's 3x squared minus 3x squared. 8x is going to cancel with the 8x, because it's minus 8x here, minus 8x, which is a plus. Minus 2 minus minus 2 is minus 2 plus 2 as well. So we're just left with this guy, and this guy. What you have to do is you have to put them over h. You have to divide all that by h. 6x plus 3h minus 8. Now, the very last thing, and a lot of people forgot this, the LIMH arrow 0 is bizarrely important. Like, a very few people actually wrote that. And if you're one of those people, the guy correcting it would have written LHS on it, because he means the left-hand side, as in you're missing the left-hand side of the question. So just if you see that on your page, that's probably what you forgot. But then what you do is you write the 6x plus 3h minus 8, and everywhere there's an x, then you replace it with a 0. And you just get 6x minus 8. And you notice if you differentiate that the normal way, that is in fact what you would get. But you do need to write all of this down on the thing to actually get the marks for it, because otherwise they don't like you, and they told me that. They said that in a group chat full of all the maths people. That's what they said. For part B. Now, if you guys skipped for part A, this is the bit I was going to say. If you were there for part A, you would have, I said something. I don't know how comfortable they're going to be with me doing the answers for the mock. I'm hoping it's not going to cause an issue. I'm hoping it's late enough that everybody would have done it. Do you know what I mean? I'm assuming if the teachers are giving them out, every school I do maths with somebody in is done their mocks, apart from the institute people. But the institute people do their own in-house mocks, so it's not. I hope it's okay, right? Maybe just don't spread it around, at least for the first few weeks anyway, because I don't want to get in trouble for this. I don't want to spread it to people who haven't done it yet, because it means I don't do maths with them and they can bugger off anyway. But yeah, just in case, just to avoid any hassle. So given that y is equal to this, find dy dx and simplify your answer. Okay, so dy dx means differentiate, use calculus, find the derivative, whatever you want to do, f dash x, whatever floats your boat. You'll notice it's a fraction though, so we're going to have to do the quotient rule. The quotient rule says that the u is the top thing, so u is equal to x squared minus x. V is the bottom thing, so it's going to be e to the power of x. Then du dx, some of you guys write that wrong. Du dx, because this bit goes on the top, whatever's in here goes on the bottom. Basically, there's obviously more to that, but I'm not going to go into that. That would be 2x minus 1. And this would be dv dx. It's just equal to e to the power of x. E doesn't change. So, then if we use the chain, or the fucking quotient rule, it says do v by du dx. So it's going to be e to the power of x multiplied by 2x minus 1. Minus u by dv dx. So it's going to be x squared minus x by e to the x all over v squared. Which is going to be e to the power of x squared. Now, when it said simplify your answer, what I'm assuming they wanted you to do was... Now, this isn't how I would do it, but this is what I'm assuming. The way you would do it, you guys would do it. Yeah, this is probably the way you guys did it, right? You guys would probably multiply it all out, and you'd say 2x minus ex minus x squared ex plus xex all over. I will leave this as ex squared for now, but some of you guys might have multiplied that out and made it e2x, which is fine. But I think this one's easier, and it's what you're supposed to do, because you're not really supposed to multiply out the bottom bit on the quotient rule, if you can avoid it, because it's easier to see if stuff cancels. Because you'll notice everything on the top has an e to the power of x, so I'm going to take out what's common now. I'm going to assume you guys in the exam would write all that out and then go, oh, wait a second. They all have it. Some of you might have spotted it in the first line. That's okay as well. But you'd have this type of nonsense over ex squared. And again, because there's two e to the power of x is on the bottom and 1 on the top, we can cancel out the squared and cancel out your boy. We left with 2x minus 1 minus x squared plus x over e to the power of x. Now there's one person I think who did well, just forgot that you can put the 2x and the plus x together. So it would have been 3x minus 1 minus x squared over e to the x. Yep, that's the answer, I assume. Again, not feeling great. What did I say? Oh yeah, not feeling great. Did make a couple of mistakes earlier, so maybe I've made a mistake or two. I would hope not. I was trying to rush again, time-wise. There's all the constraints in it, right? But again, if you think I've made a mistake, just let me know. You guys can all get in contact with me anyway. So, okay, part 2 then. So that was part 1. I didn't cop. Part 1, part 2. So, find the derivative of tan squared of 5x. Now, they wrote it a bit uncomfortably in my mind. I think they should have written like that. And simplify your answer. So, just for people who don't know, tan squared 5x is the same as writing tan 5x squared like that, with those brackets in like that. Now the square ones want to be round ones, that's just me pointing them out, so you can kind of see the difference between the two. You could use round brackets if you want to, but that is where the squared would go if we write it like that. So some of you guys just did your PTA nonsense that I hate with a fierce passion, right? Technically this is 2 chain rules, kind of. So the first chain rule would be, how will I write this? Okay, so I'm going to do like, because I know in doing the first chain rule, we're going to have to go into a second chain rule, so I'm going to set this up already. I'm going to say for the first chain rule, I would say u is equal to v squared. V is equal to tan 5x. Now this would be du dv. Again, you guys all do this wrong. Not all of you, I suppose, but a lot of you. Enough that I feel like I can say all of you, you know, with some sort of seriousness. Now, dv dx... tan, hold on, I need to look this up again. Hang on. Yeah, tan turns into secant squared. That's on page 25 of your log tables. It's obviously so uncommon that I just had to look to be sure. But in your log tables, it'll tell you it turns into secant squared, right? But there's a 5x in there, so technically I need to now you can avoid doing this, like technically speaking, but I'm just going to do it the most bare bones way, in the hopes that like if you did get this wrong, you'd at least understand what I'm doing here. And if we do it in person, I can show you like a slightly quicker way, a slightly bit more nonsense to it. But technically there's a 5x jammed inside of a tan, so to get from here to here, we actually have to do the chain rule first. So we actually have to bring this over here and pretend it's its own question, and we're going to say u is equal to tan of 5. Fucking Jesus, obviously not. We're going to say u is equal to tan of v. My utmost apologies, but this is a new u and a new, oh my god, a new u and a new v, and we're pretending like this is a whole other question. That's what the little divide there is for. So du dv would be secant squared of v, and dv dx is 5. Chain rule just says multiply them both together, but you can't leave it as secant squared of v, so you change the v back into what v is, which as we have said is 5x. And now we can bring this back around the divide and put it back in here as our answer. So secant squared 5x. And then to finish the question, the chain rule again says multiply du dv by dv dx. So that means we're going to multiply 2v by 5 secant squared 5x. But again, we can't leave v in our answer, so we're going to change that to 2 tan of 5x multiplied by 5 secant squared 5x, like so. And then all you can really do there is multiply this 2 by this 5, right? Because you can't multiply a tan and a secant together, and the 5x's are both stuck in the jail of their respective trigonometric ratio. And I think that should be the answer, but as you saw, I kind of scuffed a few of those things up, so if I was to have made a mistake, it's possible it'd be in that one. But I'm pretty sure that's right. Yeah. Yeah. Yeah, hold on. I'll put it into a calculator and just make sure that I'm actually right, so I'm not misleading you. Just for full transparency, this is what I mean when I said I was going to put it in the calculator. It doesn't actually tell you how to do it, but there's a one online that I used to use when I was in college called Wolfram Alpha. And if you go into it, it gives you just like a Google search bar, but you can basically put in some really complicated thing to do maths on. There's a few things. There's drop down menus and stuff you could go into, and it tells like on the website, and it tells you what it can do. The most difficult thing is actually figuring out how to write it in here, because you need to write it very specifically for them to know exactly what you're doing. There's a lot of different maths things that can kind of be written the same way almost, so you just have to be very specific when you're writing it in. But yeah, just as you can see, if you do differentiate tan squared 5x, it doesn't factor in into 10 tan 5x secant squared 5x. So I was happily correct, but I just wanted to make sure for you guys. I didn't want to mislead you guys. Some of your teachers might be doing the answers or putting them online, but I don't know. I don't think they'll have an explanation of a lot of them. So it says x plus 1 is a factor. It's a factor of x cubed plus 5x squared plus kx minus 12. Now, yeah, find the value of k. And that is how I write my k's. Don't judge me, but just get used to it. So x plus 1 is a factor to that. Now, there are two ways of doing this. One of them is the way I want you to do it. And the way I want you to do it is I want you to realize that if x plus 1 is a factor, that means x equals minus 1 is the root. Because with the factor, you can put it equal to 0, get x on its own, and that's the root variation instead. And then with the root, what you can do is everywhere you see an x, you should sub in minus 1, and it should, if it is a proper root, it should give you 0 as an answer. So I'm going to sub in 1 everywhere there's an x. That's my k again, don't judge. But because minus 1 is a root, and we know that, we can just slap an equal 0 at the end. Because if it is a root, we should get minus 1. Or we should get 0 as an answer. Sorry. Now, if you multiply all these out, you get this. And then if you add all of those together, you would get this. Yep. And then you just move things around. You'll end up with k is equal to minus 8. Let me just make sure I didn't goof that up. Minus k, minus 12, minus plus 4, minus... Yeah, okay. That's one way of doing it. Now, just a few of yous automatically will look at this and go, well, if it's factor, I know, I'm not stupid, I can do division, which is correct. Now, I'm going to do it out here, but if you don't want to do it, if you feel confident that you can do it the other way, you can skip. Well, for this question, you can skip this. They do sometimes require you to do this with letters, so it can be gnarly. But you do long division, and you do your normal thing of saying x cubed divided by x is x squared, so that goes on the top. Anything on the top has to be multiplied down by these two guys, so we're going to say x cubed plus x squared. But then what we're going to do is we're going to draw our line and change the sign. I'm kind of zooming through this because I want to get to the part that's difficult with the letters to kind of show you how to do that part. I'm kind of hoping you'll be okay with long division. And I'm going to do it in the next question anyway. 5x squared minus x squared is 4x squared. We bring this guy down and we get that's an arrow. I said that's an arrow. Plus kx, and then we do the whole thing again where we do 4x squared divided by x is going to be 4x. So I'm going to put that up here, plus 4x. Anything there has to be multiplied by these guys, so it's going to be 4x squared plus 4x. We're going to draw a line and change the sign because it rhymes. They cancel. Now here is where the issue would be for people. People would say k minus 4. What the fuck am I meant to do here? Some people mistakenly will write kx minus 4x. Now I say mistakenly, that is technically correct. However, it's going to make your life a lot more difficult further down the way. So instead what we're going to say is, if we had known what k was, let's say we knew k was 7. We would have done 7, take away 4 is 3, and put the answer in front of x. However, we don't know what k is, hypothetically. I know we solved it up here, and that's fine. But let's just say down here you're in a situation where you don't know what k is. What you would do is you would say k minus 4, I would get the answer of that and put that in front of the x. We don't know what that is though, so I'm going to say the answer is just k minus 4 in front of the x. Because we don't know what the answer is 3 or the answer is 19 or whatever the fuck it is. We're just going to say, oh, well, whatever the answer is, it should be whatever the answer to k minus 4 is. So that's what we're going to throw in front of that instead. Then we're going to bring down the minus 12. We're going to have this here. And then we are going to just do the thing again, just repeat it again, but it's going to be slightly more difficult this time for people. But we're going to have k minus 4. Hang on. We're going to have k minus 4x divided by x, just like we'd normally do with long division. But you notice here when the x's cancel, you're just left with k minus 4. Because the x's would cancel here and here. Then anything you put on top here, you multiply it by these. So we'd end up with k minus 4x plus k minus 4. You don't technically have to write in the bracket here if you don't want to. I prefer it that way. Oh, it is best to write in the bracket here because we still have to draw our line and change the sign. And if we didn't have it in a bracket, people would forget that the sign needs to change for everything. Now, maybe you wouldn't. Maybe I'm gaslighting you. That cancels. Now, if it's a factor, it should divide in evenly, which means a remainder of 0. That means the number down here at the very bottom should be 0. It should be. And as you can see, we don't know that. Instead, we have to do minus 12, take away k minus 4. But it should give us 0. So what we're saying is then minus 12 minus k minus 4 should have given us 0 as an answer. Should have. So we're going to investigate and we're going to say, well, that means that's minus 12 minus k plus 4 equals 0. And then you're going to put minus 8 minus k equals 0, which again, with some finagling, just ends up with k equals 8 as the answer, same, or minus 8, yeah. Minus 8 as above. Both of those are suitable ways of doing it. That line it's not that you have to do both of these ways. You either do the bit on top of the line or the bit on the bottom of the line. As you can see, it's easier if you can remember, it's far easier if you can remember that a factor can turn into its root, like I did at the top, and just sub that in. Secondary way is also okay, but as you can see, it leads to long division with letters in it, which I know you guys just don't like. But I don't know, man. Grow up. Yeah. Yep, you heard me. Part 2. Now, the reason why it's probably also better to not do do division in this is because in part 2 they say, hence find the 3 roots of the cubic. Just this guy. They're asking to find the 3 roots of this guy now. Luckily for us, we already know one of them. It's just minus 1. So we know x equals minus 1 is a root. Now, if you had done it the first way, what we're now going to do is we're going to just do division here, where we're going to say, now, we don't divide by the root. We divide by the factor. That bit needs to be established. Divide by the factor, which is the x plus 1. X equals minus 1 is the root. So we're going to divide by this guy. We're going to get this. Instead of the k, I'm going to put in minus 8x, because that's what it is. Minus 12. Now, normally in the leaving cert, what they'll do, if they give you a question like this, is they'll tell you in part I what k actually is. They'll say show, instead of saying find the value of k, they'll say show that the value of k is minus 8. Not because they want to help you with part I, but because they want you to be able to do part 2, even if you can't do part I. However, in this scenario, let's say you couldn't do part I, you just guess a number for k and use that in part 2. It might be wrong. Like, let's say you just said you guessed in part I k is 11, which it's not, and then tried to do the maths out for k is 11, you get marks in part 2, even though it's the wrong maths, but it's still fine. It will be difficult because it might not work out with the long division. However, it's fine. It's fine. It's chill. It's cool. It's fine. So we know k is minus 8, so I'll replace it in the cubic. We're looking for the other 2 factors. In order to do that, we have to do factor theorem, which means we're just going to do long division. Because when we do long division, you're going to get an x squared here. You're going to multiply them by the 2 lads on the left, and you're going to get x squared plus, or x cubed plus x squared. Draw a line and change the signs. They cancel. You get 4x squared. Now this time we're going to bring down the minus 8x. And we're going to do 4x squared divided by x is 4x. 4x by them is this. I think I did a video on long division anyway, so if I'm just going too fast here, you can always just look at that. Or put me on slower time. I don't know how that would work. I don't know if it sounds stupid. I just brought in the minus 12, but then we do minus 12x divided by x is minus 12. Do that over here. Minus 12x minus 12. Yes, sir. Draw a line, change the signs. They cancel. You get left with this big fat 0. Sick. Now we're going to look at the guy on top, the quadratic that we got left with. X squared plus 4x minus 12. Now again, you could just use your minus b formula. Or you'd end up with your answers of x equals minus 6, x equals 2. Yeah, I think that's right. Yeah, I think that's right. And those are your other two roots. So we had this one in the orange box on the top left, the x equals minus 1. And now we also know x equals minus 6 and x equals 2. So that's a cubic. They asked you to find the two roots, or the three roots for. One was kind of given to you sneakily in part I. The other two you have to get from long division. If disturbingly, so even if you did, so in part I, no matter which way of these you did it, I recommend you still do it this way. However, if you've done it the second way down here, and let's say you got it right and you knew that was your quadratic, instead of doing it all like that, again, I'll draw another line and just say this is the equivalent that you could have done, not advising it, just could have done. You could have said, well, I know x squared plus 4x plus k minus 4 is the quadratic I would have gotten on the top. And I know k is minus 8, so now I can just change that to x squared plus 4x plus minus 8 minus 4, which is x squared plus 4x plus minus 12. I don't need the brackets at this point, I suppose, but a plus minus makes a minus. And then you'll notice that we end up with the quadratic that we just do the minus b on, and you can skip all of the long division because you've already done the long division technically in part I. Now again, would I advise you to do it that way? Fuck no. But basically, if you do it that way, it just kind of cuts down to, I shouldn't really just do, yeah, I'll just write out. It cuts down to this, and that's not too bad. Do you know what I mean? That's kind of okay. But you'd have to go through this whole rigmarole at the start, which is just painful, and I don't really recommend just doing it that way. If you can avoid it, if you can't, you can't. Live your life. I'm not your boss. B, everybody seemed to fuck up B. Everybody. B says these are 3 points on the curve y equals x squared. Minus 2, 4, x and x squared. 4 and 16. And the curve is y equals x squared. Not that it's hugely important, I don't think. These 3 points are the vertices of an angle or a triangle as shown. By using a suitable translation of the points showed at the area of the triangle can be written as this. So basically what we want to do is we want to move, if you guys remember, there's a formula for it in your, you guys all tried to do the area of the triangle in different ways, but there's actually one on page 18. I don't know what the fuck I'm writing here. The area is a half modulus of, what is it, x1, y2. I don't know if I'm getting this right, but there's another way of getting around it, so I'm confident I get the same answer. We'll just see at the end, but just check on page 18 of your log tables and use that version instead. I'm just pulling shenanigans here. But in this formula, and the reason, sorry, I should highlight, the reason why I'm using this is because we were given coordinates, right? If you're given coordinates of a triangle and they ask you for the area, it's probably better to do it this way. There are other ways, but like it would take you fucking hours to do it. So we're going to use this, but you notice there's only room for x1, y1, x2, y2. So having 3 points is a bit much, and that's because we can't do it with 3 points. We need to only have 2 points, where one of them, the third guy, is 0, 0. So I'm going to make the first one into 0, 0. But what would I have to do to get to that? Well, I'd have to add 2 to the first number and minus 4 to the second number. But that's what I'm going to do with the other ones as well. You notice this one, and then I'm going to add 2 here. So that would turn into a 6. I'm going to minus 4 here. That would turn into a 12. That is a 6, just to clarify my handwriting. Now, the problem is we also have to do it here. So we're going to do a plus 2 here. So this would be an x plus 2. And we're going to minus 4 here. So this would be x squared minus 4. And then disturbingly, the 0, 0 we don't use. But we're going to say this is x1, y1. And this is x2, y2. So with this formula, you need an x1, y1, x2, y2. And the 0, 0 you also need, but we don't use that. That's just because It's an abbreviation of a longer formula. I wouldn't worry about it. Just, I'd promise you. So, if we were to sub all that in, it'd be a half. X1 would be 6. Y2 would be x squared minus 4. Then it would be minus x plus 2. Maybe it will matter if I got the formula wrong. Let me just think. 12, like so. It'd be a half. 6x squared minus 24 minus 12x minus 24. Yeah, so it probably does matter that I fucked up the formula. Let me... I suppose it's not... I'm not wrong. It just says show that it can be written as this. So I'm going to have to look at it and just see what way around the formula is. Because you notice the way I have it is... Oh, no. Okay, they're just being perverts about it. Alright. So, 6x squared minus 12x minus 48 is what I would get if I put the two 24s together. Now, we don't really tell you guys to do this, but because they're all whole numbers, we can just put the half into it. And I know it seems weird messing up the modulus and the non-modulus things, but it can just be written like so, where you just half each of the numbers. And that's fine, so that's okay. I don't know how you're going to feel about that, because that isn't... We kind of don't... That seems like dark arts kind of stuff. It's fine. It's fine. If you think about it, the modulus only really cares about the minusing, and by multiplying in the half, it didn't actually change anything. So we're actually okay for the moment. Calculate the value of x so that the area of the triangle is at a maximum in the domain between minus 2 and 4. So, the value of x so that the area of the triangle is a maximum. Maximum means differentiation. Differentiation with the modulus bars, though, is kind of gross. But let's say we differentiate it to be 6x minus 6. I suppose, yeah, I suppose, yeah, we'll just do that anyway, because that's f dash x. And then for the maximum, you'd put it equal to 0. 6x equals 6, x equals 1. Calculate the value of x. Alright, well, is that then? If I subbed in 1, it would be... the area of the triangle would be 27. So hypothetically, if I subbed in 2, let's see. Now it says the area of the triangle should be a maximum when x is 1, and I got 27. So if I sub in 2, I should get a number smaller than 27. If I do, I get... No, I get a number bigger than that, no? If I subbed in 2... no, I was being stupid. If I sub in 2, I will get 12. Take away 12, I get 24, which is smaller, which is what I want. If I sub in 3, I would get 27 minus, so I would get 9. Yeah, smaller again. Okay, sick. If I sub in 0, I get 24. Yeah, okay. That actually seems right. Okay. I've never really run into the one where you have to kind of just differentiate and kind of ignore the modulus bars. That's bizarre, but it works. I'm promising you it works based on just the quick maths I just did. So, congratulations. You're welcome. What is this? Question 6. Yeah, that seems a bit bullshit, that last one. But, just kind of pulled shenanigans and it just kind of worked out. But the diagram below shows the tangent line. I suppose in that last one, differentiating kind of gives you the slope. And the slope doesn't really care whether it's up or down or whether it's a positive or negative value. It just is telling you how much it's changing by. So I suppose, yeah, it kind of makes sense. I'm sure there's some mathematician who'd go deeper into that. Maybe some of the teachers know. Yeah, I would just kind of go, it seems fine. But we'll see. 6a part I has a graph, right? I'll try to draw that in somewhat. So it has it like this, 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 and then has a tangent like this. Again, I'm hoping you guys have it in front of you so I don't need to... My diagram can be this shit and you'll still know what I'm talking about. And this is fx equals x squared, I'm assuming. X squared over 12. Oh. Okay. Now, it does show a tangent line at the point M. That's going to be important later on. Find the derivative of fx with respect to x. Some of you did quotient rule, and that's fine. The thing is, you didn't need to. Hang on, it's saying you did. Oh, yeah, okay. Some of you did the quotient rule, and you didn't need to. The only time you need to do the quotient rule technically is when there's an x on the top and on the bottom. So here, because we had fx equals, so this means I'm gonna have to clear my screen, I suppose, because it's just it's lagging a bit. X squared equals, or x squared over 12, but that's the same as 1 over 12 x squared. You can kind of deconstruct it like that. And if we're differentiating, if you're ever just differentiating an x with a number in front of it, you just drop, or sorry, never mind what I just said. We have 1 over 12. You differentiate in an x squared, that turns into 2x. Multiply them together, you put that over 1, you do top by top, bottom by bottom, you end up with x over 6, or if you want to, you can write it as 1 over 6x. Both of them are the same guy, right? Whichever one you pick is fine. But yeah, that's what the derivative is of that curve. Now, part 2. So again, just to explain what that means is if I wanted to find the slope here, for example, on the curve, I would find out what its x value is down here. That goes with it, like boom, 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 boom. And then I would sub that into x over 6, and it would tell me what the slope of the curve is at that point. It says the tangent to the point has a slope of -2. So the slope here is -2. Find the equation of this tangent and give your answer in this form. Wouldn't worry about that until we get an answer. So the equation of a tangent means we're going to have to do the y minus y1 equals m bracket x minus x1, because the tangent is just a straight line, and this is the equation we would use to find a straight line. We know the slope is 2, well, -2, sorry. But we don't know what the x1, y1 is, because for x1, y1, we need a point on the tangent. And we don't have any. So what we're going to do is we're probably going to need to find m, because you notice that is a point that is on the tangent. Now, how are we going to find m? Well, luckily for us, the reason why I think it's the one we're going to find is because it's also on the other curve, and the curve is the only thing we actually know about. So we're probably going to have to leverage that in some way. And basically, if you recall, when I'm teaching you guys the slope, what I would do is I would zoom in on this part of the curve until it looks like a straight line. Like, you know what I mean? I would zoom in on that until it looks like this, and I find the slope of that one and just kind of say, well, that's the guy. Because if we zoomed in here, if you zoomed in there, the tangent, or the curve, kind of look like that, but the tangent would kind of look like this, and they're basically the same, right? So when the tangent and the curve touch each other, they have the same slope. When the curve and the tangent touch each other, they have the same slope. So that if the tangent has the slope of -2, the curve has a slope of -2 where they touch. Nowhere else, well, maybe somewhere else, but like literally it's just where they touch we can say is -2 for certain. Everywhere else would be different, we're going to assume. So what we're going to say is the slope of the tangent is -2. The slope of the curved line is -2 here. Nowhere else, right? So our job is to kind of find out where is the slope of the curved line -2, because that must be where it matches. So basically, I'm trying to find the value of x. How do I describe? Yeah, the value of x that I can put in here into one of these two that will give me -2 as an answer, because I know then that must be the point where the curve and the line are the same. How do I describe this? I know I'm just not saying this properly, and I know there are people confused by this. Slope of the curved line is different everywhere. Like here the slope line could be 1, here it would be 2, here it would be 4, here it would be 7. Because they're all going up, so they're all positive. Here it would be like -1. Here it's going to be -2, and the reason I know that is because it's touching the tangent at that point, and the tangent is a slope of -2. They have to share the same slope when they're touching. But here, this would go to like -4, and this go to -7. But where there's contact, they will have the same slope. If it's a tangent, they will have the same slope at the exact same spot. So if I want to find out about the point M, I just know that we're talking about, I don't know what the x is, I don't know what the y is, but I know the slope is -2, and I know we have a slope formula. for the curvy line. So what I'm going to do is I'm going to put my slope formula equal to -2. Now, I don't think most of you would use that one. I'm going to put my slope formula equal to -2, because we know that. We know the slope of the curved line is -2. We know this is the slope formula. Put them equal to each other, multiply both sides by 6, and you find out that the x has to be -12. So I know the point M, where am I going to write it? The point M is -12 and something. So that means over here I can put in -12 in my x1 spot. But we still don't know what the y is. How do we do that? If only we had a formula that said y equals. But we do, it's just in disguise. Don't forget fx is code for y. So what you'd have to do is you'd have to go up there and say fx is equal to x squared over 12. But that means that f -12, basically just subbing in -12 everywhere there's an x. And you put that in your calculator and you get 12. Yeah. So now we know this is 12. Because the y formula, again, don't forget this is code for y, is x squared over 12. So I just subbed in -12 everywhere there's an x. And I found out that when the x is -12, the corresponding y has to be +12. That's what I put in here. That means we know the y1 is going to be 12. And now I can finally finish off the equation of the tangent of the line. That's a very difficult one. If people want to ask me about that in real life, I wouldn't be too upset about that. Do you know what I mean? Because I understand, even me trying to explain it, I feel like people aren't going to get that from my explanation, not just the question even. Now it says give your answer in the form of y equals ax plus b. So that just means they want y on its own. So I'm going to hike the -12 over and make it a plus. And we get this. Yeah, and that's the equation of the line written in the format that they wanted. They wanted it as y equals ax plus b. But my a and b are just -2 and 36. That's all. That's all. Now it shouldn't be, because it should be -12. I misread what I was doing. It should be -12. Sorry, my apologies. Yeah, -12 is correct. My bad, y'all. My bad. You probably also would have gotten marks. Yeah, I'm just saying this girl actually did it this way as well, and she got marks for. She said, well, every line has to look like y equals mx plus c, where m is the slope. And they flat out just told us the slope is -2, so I'll just write this. Now, obviously finding c is, you can't really find c in that way, but she got half of it, so congratulations. Congratulations to her, guys. I'm not telling you who it is. Don't ask. Don't ask. Now, part B part I. So on the next page, as again you hopefully will all have it, they draw a line like here, and they shade in all of this part. And they're going to ask us, I'm assuming, what's the area of that? Not straight away. Show that the equation of the line perpendicular to the... Oh, okay, I forgot to mention. They also mentioned that this orange line that they've drawn in now is perpendicular to the line that was already there as the tangent line. Show that the equation of the line perpendicular to the tangent line passing through the point M can be written as this. Oh, it's passing through M. Hold on. Okay. Oh, I'm going to have to just redo all this. I didn't realize it was passing through M. So it has to obviously be a line going kind of like this, because it has to be going through the M point. And it is perpendicular then to the tangent. That's supposed to be 90, but I can draw it on this side and you can still see it. And all of this was what was shaded in, so that's not bad. That's not bad. Now they said show that the equation of the line perpendicular to the tangent passing through M, which is this orange line, show that it can be written as y equals x over 2 plus 18. Well, again, that is a straight line, so I'm going to use the equation of the line formula, which is the y minus y1 equals m bracket x minus x1. Now we need a slope and a point. Well, we know the point because it says it goes through M, so we're still going to have the same x1, y1. So we're going to have y minus 12 equals something x minus minus 12. What's the slope? Well, we know the slope for the other one was minus 2. So if the slope is minus 2, that means the perpendicular slope is, you have to flip it upside down and change its sign. So we're going to flip the minus to a plus, and we're going to flip 2. Don't forget 2 is sneakily 2 over 1. So it changes to 1 over 2. It's not just plus 2. That's what they were trying to catch people out with. But you'd have to flip the 2 upside down, and you might say, but there is no fraction, but there really is in disguise, and that's what happens here. If you're left with a fraction here, instead of dividing by 2, you whip that across and make it multiply instead. We'd have 2y minus 24 equals 1 multiplied into this bracket. Give me just x plus 12. Yeah, and we want y on its own again. Yeah, so I'm going to say 2y is equal to x plus 36. I'm going to divide everything by 2 because we want the y on its own. We're going to have to x over 2 plus 18. Wow, that's what they wanted. That's crazy. I don't know whether I'm skipping things that you guys would want. Again, if there's any issue with any of the questions, just text me and be like, hey, what's the dealio with question whatever, do you know what I mean? Or, yeah, I'll try clarify. If enough of you do it, I might actually realize I need to say things differently. So it says line perpendicular to tangent at M also cuts the point F at the point N. So it kind of says up here, there's a new point called N, shown in the diagram below. Find the area enclosed by this line and the curve y equals fx. So they want the area enclosed by the curved line and the straight orange line, the shaded in bit that I've said here. Now in order to do that, we have to integrate it, where we do the top line take away the bottom line. So in this shape here that we would have, the orange line is the top line and the curved line is the bottom line. We know the top line's equation is y equals x over 2 plus 18. We know the bottom line's equation is x squared over 12. I should have y equals, but you know what I'm trying to say. And then when you're doing this, if you want the area in between, you would do the top line first and then the bottom line second. So we do this, and then we do minus the second one, which is x squared over 12. And we write dx, because you have to write dx. It's also suitable to write them separate. I just don't want to. But I'll show you that that's what you could have also done as well. You could have also done it like this. You have to write a dx after both of them technically. This is what some other people would do instead. But you notice it's just kind of the same thing. Whatever floats your boat, I literally do not mind. Now, we have to integrate. Now, you'll notice we don't know the limits. Right? So, we know we're integrating between here and here. But we don't know where they are. Like, if you look on the thing, it would be like here and here. Now, the thing is, we actually already know one of them, because we know the x value of m is minus 12. So we know that the smallest limit is going to be minus 12. And we know that because this point here is m. And we know m has an x value of minus 12. So that's how I know this number down here is minus 12. We just need to find the x value of n. Because whatever is here is just going to go in here. Now, how do we do that? We have to find the point of intersection between the two curves. So we have to do, as an aside, we have to, or get to, do simultaneous equations. So up here I'm going to do y equals x over 2 plus 18. I'm going to do y equals x squared over 12. Now keep in mind, originally they didn't say y equals this, they said fx. But fx and y are the same thing, so it doesn't matter which way around you write it. Now, there's a couple of ways of doing it. I'm going to do it here kind of cheekily like junior cert ones, where I'm going to multiply everything in the top line by minus 1. So that'll be a minus, that'll be a minus, and that would be a minus. And then if we add them together, the y's would cancel, and we're left with x, well, we have equals 0. I forgot to say that because there's no y's left, so we have to say equals 0. We're left with x squared over 12 minus x over 2 minus 18. You multiply that whole line by 12, and it turns into 0 equals x squared minus 6x. 12 by 18. I know this. I'm just tired. Don't judge me. 36, 72, 216, I think. And then you notice, oh look, it's a quadratic. And you do your minus b. Now one of our answers should be minus 12. So the other answer should be 18 just. Yeah. But you guys will use your minus b just to make sure that those are your two answers, 18 and minus 12. But that means when we go back here, we can put the 18 in here, because that is this number. Because that's the x value of our points of intersection are 18 and minus 12. We already knew minus 12 was one of them, so it was good. We got it as an answer. The other one is just 18. Normally in simultaneous equations, we have to find the y. But for integration, we literally just do not care, because we only need the 18 and the minus 12 to be limits. So now what I'm going to do is and it would be the same here if you were doing it this way. But I'm going to have to actually do the integration now. X turns into x squared divided by 2. Now, what way would you guys write this? You guys would probably write it like this, x squared over 2, but you're still dividing by 2. Then the 18 would become 18x. And then over here, you guys would write it as x cubed over 3 all over 12. Now, I say you guys, there is a different way of writing that, but I'm just going to write it the way that I think you guys would write it the most. But, yeah, how do I explain this to you guys? If you have x squared over 2 over 2, this 2 is like dividing by 2 over 1. And if you're dividing by a fraction, flip it upside down and multiply instead. So we'd have x squared over 2 multiplied by 1 over 2, which would end up being x squared over 4. In a similar fashion, when we have x cubed over 3 divided by 12, it's like being divided by 12 over 1. But again, then we're going to flip the bottom fraction and multiply by it instead. So we're going to multiply by 1 over 12 instead. Yeah, okay. Sorry, people are texting me at the same time. I'm just trying to make sure there's nothing that I'm like they need me for in the moment. And that's what that would turn into, right? If you were to do it that way. Now, the problem is your calculators obviously would have an issue with the x's. If you just didn't like what I just did there. So like, let's say you didn't like how I did this one. You could do it on your calculator like this, but just put a 1 in place of the x squared. And it would tell you that the answer is 1 over 4. But then you would say, oh, there was an x squared in here initially, so I'm going to shimmy an x squared in here as well. Oh, look, it's the same thing. Do you know what I mean? That's another way of doing it. If you're unsure, but that's how that kind of breaks down. I'm not going to spend too much longer on that. I was going to say too long, but I've already spent a long time, because the main issue is the integration. If you want to talk about the algebra of it, again, just let me know. Do you know what I mean? X squared over 4 plus 18x minus x cubed over 36. Sub in the 18 and the minus 12. I probably just won't do the actual number part here. I'm kind of hoping you guys would be okay with actually just doing this. Like, you know, you just throw it on your calculator and it'll be fine. I just don't have to look for it. But I'm going to write out what you technically have to do. Now, you'll notice I have to write the brackets on the minus 12. I didn't write it on the 18 squared, but the minus 12 squared, it is imperative that you do that. Really important. For those of you who asked what that means. Minus 12 cubed 3, 6. And you would do that and you would get your answer. I'm just quickly looking over to make sure that I subbed everything in right, because I hate to send you merrily in the wrong direction. Yeah, well, I'm just gonna put a little cut here so I can kind of save the video anyway, so there's no issues. Okay, I'm gonna try this next one again. This is the long questions, I suppose, but I am starting to tire, so I will start getting sloppier and making a few more mistakes doing this. So just be warned ahead of time. Like I'm assuming you guys are almost able to all vote at this point. I'm hoping you will be able to just spot if I fuck something up and not instantly text me and be like, you wrote a plus instead of a minus, you dickhead. Aiden is a hydrogeologist, alright, who was drilling a cylindrical bore with a diameter of 16 centimeters and a depth 35 meters. Yeah, a lot of you guys made this mistake where cylindrical, so we know it's a cylinder, so we're going to go to your log tables and find because it asks you to find the volume. Sometimes they say capacity, but that means the same thing. So there's volume of a cylinder, which we all know is pi r squared h. Now, a cylinder looks kind of like this, where h is here, and the radius is half of the width of it. Now, the problem is, it says a diameter of 16, and you guys all went, well, I'm not stupid, I know the diameter is here to here, so that means that the radius, if the diameter is 16, the radius is 8. So you all went, yep, perfect, pi 8. And then the problem is, you said height is the height, and they said the height is 35, so I'm going to put in 35. But the problem is, it says 35 meters and 8 centimeters. So we actually want them, we can't have them in different kind of modes, if you know what I mean, before we go into it. So we need to change 35 meters into centimeters. And that's 3,500 because there's 100 centimeters in every meter. So that's what we would have had to have done instead. Now I will need, oh God, hang on, I will need a calculator. So, hang on, I need to... Yeah, okay, we'll do it this way. So you'd write it all out like that, and you'd put that in your calculator, and you would say it's multiplied all together, and you would get 703,716.7, smooth 7544. Now that would be centimeters cubed, because we put centimeters into it, and it is a volume formula, so it'd be centimeters cubed. However, that's not what they asked. They asked for the volume in liters. They also told you 1 liter is the same as 1,000 cubic centimeters. So all you have to do now is divide that by 1,000. And that should tell you your answer to be 703.7167544. But it said correct to 1 decimal place, 703.7 liters, I guess. Okay, underground water flows into the bore. Aidan pumps all the water from the bore so that at the time t equals 0, the bore contains no water. He then turns off the pump. The bore starts to fill up again, alright, with water. The volume in litres of water in the bore t minutes after the pump is turned on can be modelled by this function. Alright, so like none of that is necessarily sick one. Volume is equal to this shit. By differentiation, show that the net rate of water flow, or t, can be written like this. This is absolutely AIDS. That's crazy. 7 part A, firstly, I should have written. And then this would be B, I. Now, what I mean is by that, I don't think you guys would have really done well with this because there's a lot going on. Hopefully I do okay with it. Vt is equal to T ln of 10t plus 1 plus, what's this, ln 10t plus 1 over 10 minus t. Now, I'm going to point out, I'm going to highlight something, that there's an ln that matches with this ln over here. So, oh, there's something just nasty you could do with that, in all honesty, but I'm not going to. We're just going to keep note of that, because I'm going to mention that in a second. Now, to differentiate it, in order to differentiate this guy, technically it's a product rule because there are two elements with t being multiplied together. The t and the ln of 10t plus 1. So for the product rule, I don't know where to do it where it's not going to be a mess. For the product rule, I'm going to say u is equal to t, v is equal to ln of 10t plus 1. Then we're going to have du dt is equal to 1. dv dt is equal to 1. Oh, now we have to do chain rule technically. So what we're going to do is we're going to take this over to here, pretend it's a whole new question, and we're going to say u is equal to ln of v, but v is equal to 10t plus 1. And then we're going to differentiate both of those. Du dv is equal to 1 over v. dv dt is equal to 10. Don't forget, for things like that, you can look in your log tables for ln of whatever. Chain rule then says multiply them both together, but instead of 1 over v, we have to replace the v back with what we had it up here. Now you can multiply that by making the 10 into a 1 and doing top by top, bottom by bottom, so you'd have 10 over 10t plus 1. Do not try cancel those 10s. Those 10s do not cancel. You know, if you want to cancel something out of a fraction, you have to be able to cancel it from all the parts. So this part, and this part. And because we can't cancel it out of the 1, we can't cancel it. So we're just going to have to leave it the way it is. I know you guys are all just dying to do that. But now we're going to shimmy it back up here, and that's going to be our answer to this. And now we get to finish the product rule. What a great day. So product rule says you do u by dv dt, so that's going to be t multiplied by 10 over 10t plus 1, plus v by du dt, so it's going to be ln of 10t plus 1 multiplied by 1. Now I'm going to multiply the t into the fraction. I'm not sure if I want to yet, but I'm going to do it. So I'm going to put it over 1. I'm going to say that's 10t over 10t plus 1. You can't, for the love of God, do not try cancel that again after I just said I can't believe you guys. And then multiplying by 1 is just, the same guy. So that's that bit, right? So all of this is done now. Whoops. All of this is done now. And all of that turns into 10t over 10t plus 1 plus the ln of 10t plus 1. Now for this guy, again, we don't have to do the quotient rule technically, because you only have to do the quotient rule if the letter you're differentiating by is on the top and on the bottom, but there's no t on the bottom. So technically what you could do is, I'm going to write this somewhere else. I know this is a mess, but it's just me trying to explain it all. You could rewrite that as 1 over 10 bracket ln of 10t plus 1. You don't have to. You do not have to, but if it just makes more sense to do it that way. Because if you recall, the ln of 10t plus 1, we already differentiated when we went into this chain rule bit over here. So we actually know what that is differentiated already. If you want to, you can do the whole chain rule again. I'm not going to judge you for doing the chain rule. You guys know I love the chain rule. But we already know that when we differentiated this, it turned into this. So if we were to differentiate this, it would turn into 1 over 10 bracket 10 over 10t plus 1. Right? Because then the 1 over 10 you don't change, because that's just a constant in front of the thing that we're differentiating. This would turn into this, though, based on what we did with our chain rule earlier. I don't know how the fuck any of you guys are going to follow this. I'm just having fun at this point. I'm just flying through shit. I'm having a grand old time. Thanks for making me do this, guys. Actually, I needed this. I don't know how the fuck you guys are going to handle it, though. That's going to be hilarious when I start getting a deluge of texts of like, what the hell is this? Where did this come from? Why don't you use different color pens? The purple and the orange are gross. They're not together on the color wheel. I don't know what that is. You guys need to stop bringing it up. But basically, this fraction would turn into this. Now, I said earlier you can't cancel things unless you cancel them all out of the entire fraction. So in this fraction we can't cancel a 10 out because it's not in all of the things. In this fraction we can't cancel a 10 out because it's not in all of the things. However, in the combined fraction there will be a 10 on the bottom and a 10 on the top that are being multiplied together, and then we can cancel them, right? So if I multiplied these together and did top by top, bottom by bottom, I'd be 10 over 10 bracket 10, 10t plus 1. And then I can cancel them here and here. Because technically the 10 being multiplied into this and this means it's technically in all of them. And I said you can't cancel it unless it's all of them. Technically that 10 is. I just don't want to multiply the 10 into them and then hide the 10 inside of them. I know there will be 10 attached to all three elements, so I'm just going to cancel it out. But the one issue with that is it's not just nothing on top. It's not that if you cancel out the 10, it's like, oh, it's gone. That means the fraction is gone and the bottom part is freed from its prison of under the fraction. No, it's just 1 over 10t plus 1 now. There still has to be something on top because 10 divided by 10 is 1. Now again, I'm going to draw a line here because I understand it's looking like a fierce mess right now. But so what I'm trying to say is that whole fraction turns into this. Because we'd already done the ln of 10t plus 1. We just had the extra contender of the 1 over 10, but that just cancels with the 10 that was in our previous answer and cancelled, and we're just left with 1 over 10t plus 1. Hopefully that's okay. Again, if you have any issues, by all means bring this up with me at any time. I do not mind, because I understand this is difficult shit. Minus t, though, if you differentiate it, it's just minus 1. Because if there's a number in the letter, we just drop the letter. Happy days. Now, it did actually say, show that it can be written as something else. So let me see what they want me to make it look like now. Show that it looks like... Show that the net rate of water flow, RT, can be written as this. So basically, I'm assuming they just want me to kind of add all the shit together. Oh, that's so stupid. So, you'll notice that we have two fractions that have a common denominator, here and here, so we can add them together. So I'll write that bit in orange. Hold on, I'll write the other bit. So we still have ln of 10t plus 1 minus 1. But then this fraction, these two fractions added together, because they have a common denominator, we can plus them together on the top like this. Sorry, I forgot about the t. So basically, if you have a common denominator, you can just mush them together as one mega fraction that only has 10t plus 1 on the bottom once. You don't need to write it twice, just the once. And then you add the top parts. It'd be like saying if you have 3 over 7 plus 2 over 7, that becomes 3 plus 2 over 7, which is 5 over 7. What a happy day. We would do the same here, but obviously everything looks yuck. Just gross. But oh look. If you just look at that fraction, the top parts and the bottom parts are the same. So we're dividing 10t plus 1 by 10t plus 1. So all of that breaks down to just plus 1. All of that is gone now because it was just dividing something by itself. In the same way that, like, if you did 6 divided by 6, you get 1. If you do 10t plus 1 divided by 10t plus 1, you get 1. But then you have a minus 1 and a plus 1. So they cancel because plus 1 minus 1 is cancels. And you get left with ln of 10t plus 1, which is what they wanted to show that RT was equal to. Again, like, lads, I had a good time there. If there is an issue, let me know. I do not mind. Showed it's ln of 10t plus 1. I did that, guys. I did that. Now, table mode. As far as all the ones I've seen so far, you guys all smashed the table mode thing, and I'm happy with that. Hopefully then it's okay with you guys are okay with me not writing that out, but you could go to your log or your calculator and go into table mode, put in ln of 10x plus 1, because you can't put in t obviously, and then do from 0 to 12 with a step of 2. Alternatively, you could just sub in the numbers one at a time yourself by hand. That's also fine. That would also work. The graph, yeah, these are all okay with the graph. I'm assuming how to graph a point. Now, you might not be, but ask me that in person, because just writing it out here is just difficult and annoying. Find the average rate of flow of water for the first 12 minutes after the time the pump is turned off. So, average of a function for the first 12 minutes is what they're asking us here. Average of a function means integrate. So, we have to integrate the rate of flow, which is the RT, so ln of 10t plus 1, or like our answer from before. This would be dt technically, because that's what we're differentiating with respect to. It says in the first 12 minutes, so that's going to be in between 12 and 0, right? Because the first 12 minutes starts at 0 minutes and ends at 12 minutes. You guys all remember when we're doing the average value of a function, we have to integrate it over the time, and we have to do 1 over b minus a at the start, right? That's the way they teach you guys. 1 over b minus a, and the way you would do it is you would say 1 over b is 12, a is 0, and then that would turn into 1 over 12. I don't do it that way, so that's why I didn't write it like that initially, but I should write it this way because that's the way you guys learn it, so I'll do it that way. So I'll say that turns into 1 over 12, that fraction. Now, there's a trick here. We have to integrate ln of 10t plus 1, but we started with this shit. We differentiated all of that shit and got it down to here. Integration is the opposite of differentiation. So without doing any maths, I just know that it's going to be the reverse and bring us back to this line here. So without literally doing any maths, I can just say I know that the answer is going to be t ln of 10t plus 1 plus ln, it's still a fucking mouthful to be honest with you, 10t plus 1 all over 10 minus t, 12, 0. Now, hold on, let me just make sure, because I want to say something, but I want to not sound stupid. Okay, so basically, with these questions, I will always tell you that if you're subbing in 0, don't just assume everything will turn into 0, but here it will. So we're going to do that. 1 over 12. Sub in 12, everybody does in t. I hear something like a radio or a TV on, but it's not in my room. I'm hoping you guys don't hear it. It's not in the room I'm in, so I can't be blamed. Now technically we'd also have to do it again where we sub in 0 everywhere. Now again, play it safe. In the leaving cert, actually sub in a 0 and just make sure each of them turns into 0. I'm promising you here that this does in fact turn into 0. But then, yeah, you would just slap all of that into your calculator. And I've lost the question, so hang on. Sub it all into your calculator, and it asks you for it correct to 2 decimal places. I'm not going to sub all that into my calculator if that's all right with you guys. I will, however, point out that I wrote something wrong here in this fraction. The 12 should have been in a bracket, not the 12 plus 1. It should have been like that. You guys can rewind and see what I've changed. Because I subbed in the 12 in place of the t, I should have just wrapped that in a bracket. My apologies. But you would just slap all that in your calculator and just don't forget the 1 over 12 at the start. And that would be the average rate of flow for the first 12 minutes. Okay, I'm going to start question 8, but I'm going to have to go now in a minute to do something. So start question 8, see how far into it I get, and then I'll just come back to it and repeat it. So there might be a break in a minute, but just you guys are grown-ups. 8A. Yeah, now I've done this with, well, I looked at this with a few people. What is it? The amount of blood samples that arrive T hours after 8 a.m. on a particular day is 650. Yeah, I haven't actually done this with anybody because you all skipped this one, I think. T root T E minus 0.8 T. Like, it just sounds like Alexa or something has gone off, but it's not. I'm just kind of baffled by it. MT is equal to this, where the rate at which blood samples arrive at the laboratory. MT is measured in samples per hour. Alright, show that M-T is equal to this. That just means differentiate. That's all I'm going to do. Now, the thing is, if you want to differentiate this, you'd have to recognize there's actually 3 elements with T's being multiplied together. So technically, we'd have to do the product rule twice. So technically, you'd have to do the product rule with this, get the answer, and then recognize that it's going to be multiplied by this, and it's going to be just a fucking mess if we try to do that. Well, okay, no, I phrased that wrong. I don't want you to think it's something else, actually. What we'd have to do is we'd have to do like this, and say this is U, and this is V, and then do the product rule, but when we get to du dt, we'd have to make a new product rule. We have to do another one where we make a new line, and we say U is equal to T, and V is equal to the square root of T. Do another product rule, yada, 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 get the answer, zip it up back in here, finish the product rule, yada, 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 and then be on your merry way. But the problem is, when you're doing this one, you actually have to do it. You don't have to do a chain rule, actually. They give you that in the log tables. You'll be fine, actually, if you did it this way. If you did it this way, you'd actually work out fine. Just a bit weird. However, I'm going to do it a different way because I'm genuinely curious. Maybe I'll cut this out if it goes wrong. But there's a way I'm thinking of doing it, and it works. I'm just afraid it won't give us it in the form of the answer that they were asking for necessarily. And I might have to move shit around, and at that point it might get too difficult. Don't forget, the square root of t, another way of writing that is t to the power of a half. So instead of writing square root of t, I can change that to t to the power of a half. But then I'm multiplying a t by a t to the power of a half. And if you multiply those two together, you just get t to the power of 3 over 2. Just using your indices rule, top of the first column of page 21 of your log tables. You can just change that to that. So it'll be 650 that e minus 0.8t. Then we need to do the product rule once, where this is u and this is v. I'm just curious if this is going to work, to be honest. The 650 is a constant again, that's going to be multiplied by everything at the end, so I'm just going to almost not write it until the very end. That can be problematic because you can kind of forget to put it in. So if you want to write the 650 the whole time, you guys do what you want to do. I'll write all the product rule bit in orange so that we can keep track of it. So u is equal to 3 t to the power of 3 over 2. That means du dt, if we differentiate, would be equal to 3 over 2 t to the power of a half. V would be equal to e to the minus 0.8t. That's just using the same thing where you multiply in front by the power and then lower it by 1. You might need to do 3 over 2 minus 1 on your calculator just to be sure. That can sometimes get messy. Now, dv dt, it tells you in your log tables, if you differentiate an a to the ex, it turns into a e to the ax. Here, minus 0.8 is taking the place of a, so that's just what I'm going to do. I'm just going to say that it is minus 0.8 e to the minus 0.8 t. And that's that. Hopefully you're okay with that. I literally just took this step from here to here from your log tables on page 25, right? It's in the box on the left hand side. Now, product rule says to do u by dv dt and then v by du dt. So I'm going to have t to the power of 3 over 2 multiplied by minus 0.8 e to the minus 0.8 t plus 3 over 2 t to the half multiplied by e to the minus 0.8 t. All of this still being multiplied by the 650 on the left, don't forget. Now, I'm going to have a look at what format they wanted it in, because if it's nowhere near that, I'll cry. No, I think it's chill. I think you boys done it again. So if we multiply both of those by 650, we get 650 t 3 over 2 multiplied by minus plus, and then 650 multiplied by this shit. And I'm assuming, I'm not going to do the maths, but I'm assuming if you multiply the 650 by the minus 0.8, you will get the minus 520 that they have. That's just an assumption I'm making. And I'm also assuming that if you multiply 650 by 3 over 2, 1.5, you will get 9. That one is true. You do get 975. T to the half, e to the minus 0.8 t. But they don't want it written like that. You'll notice for the minus 520, they want it as t root t. But as we said earlier, t root t does turn into t root, or t 3 over 2. So I can split it up in a similar fashion. I can break it up as t to the power of a half. But then instead of power of a half, I'm going to write it as a square root instead. You guys honest, let me know. Let me know if this is fucked up, right? 975 t to the power of a half is the square root of t, e minus 0.8 t. And that's what they want. Now I've written it backwards, but that's okay. As long as the plus is in the right place and the minus is in the right place. And your heart's in the right place, do you know what I mean? Maybe the friends was the maths you made along the way. Hence find when the rate of the blood samples arriving at the laboratory is at a maximum. Ooh, you terrible, terrible people. So, maximum means that you need to put the derivative equals to 0. So that means we're going to take this bullshit from here and just put an equal 0 at the end of it. T root t e minus 0.8 t is 975 root t e minus 0.8 t equals 0. There we go. Now, there's some strangeness here, right? So what I'm going to do is this is going to upset some people. I'm going to take out what's common, which is a root t. I'm going to have root t minus 520t. I'm also going to take out the e to the minus 0.8t, actually. It's easier to do it that way. plus 975 equals 0. Now, if there's 3 elements being multiplied together and giving me 0, the only way that can happen is if one of them is 0. So I'm going to investigate all 3. So I'm going to say minus 0.8t, and the power is equal to 0. I'm going to say root t is equal to 0. And I'm going to say minus 520 t plus 975 is equal to 0. Now, this just can't happen. This is no bueno. I guess I should explain. The letter we're looking for is stuck inside of a power. We are going to use the top right of page 21 again. Now, I'm just going to let you know that this turns into this. But you can't do that. ln is 0. Let me just slap it in the calculator, make sure I'm not just delirious, right, with just tiredness. ln of 0, if you put it, log base 0, log base e of 0 is a math error. Yeah, that can't happen, right? So, log base e, so that one just is inconsequential. It's not, that one can't get us to 0, so it's not that one. Root t is equal to 0, you square both sides, and you get t is equal to 0. And that's one of our options. Then over here we bring the 975 to the other side. And then divide both sides by minus 520. And then what we'd have is, let me see, minus 975 over minus 520. 15 over 8. Now, I'm going to have to go and take a... I have to go do stuff, so it's going to be a break in the... Well, you guys won't notice it probably. But those are I'm not finished this question, by the way. Those are the 2 t values that will give you a slope of 0. So that means one of them is going to give us a maximum, and one is going to give us a minimum. I don't know yet, but we're going to figure it out in the... I don't know, I'll come back next time. For you guys, it's like in a second. Hang on. Alright, so... If I remember when I left off, I was trying to find out when, so it was to find the maximum, and I found the two issues when found the 2 values of t that would have given us a slope of 0. That's what we found. We found out the 2 values that if we had subbed them in to this guy, which if you remember is dy dt, or dy dt, or f dash t, depending on how you want to write it, which is the slope formula, it should have given us 0, right? So that's just what those 2 numbers represent, the 0 and the 15 over 8. But the problem is, if the graph is something like this, one is a maximum and one is a minimum like that, but we don't know which one it is. Like, we don't know which one of these is the maximum, and we don't know which one of these is the minimum. So what we can do to find out is, you can just sub them both back in to the original function, and just see what's what, like this one over here, right? Because if you sub it back into this, it will just give you 0, because that's what we said. It's the number that we'd have to sub in there to get 0. So there's no point subbing it in there. You'll just get 0 for both of them. We're going to sub it in to this guy. Now, when you sub in 0 to that, I'm pretty sure all that happens is you get 0. You might want to check that in the calculator just to be sure. But I suppose it makes sense that they don't get any blood samples at 8 a.m. in the context of the question. So that's not... It's not crazy, I suppose. And if it's been 15 over 8, hold on, I guess I'll just type it on the calculator, hang on. Yeah, when you sub in 15 over 8, the way it works out is you end up getting m of 15 over 8 to be 372.37, we'll say. So clearly that's the higher one, so that one's going to be the maximum. Which is fine, perfect. Okay, so what was the question though specifically? Because there was a break and I've lost track of what the question actually asked. So it actually asked you to find the rate of blood samples arriving at the laboratory. Oh, find when. Oh, sorry, just find when. So we actually didn't need to do these parts, because it just said find when. No, we didn't need to do these parts. I lied to your face. So it said find when, so this is the answer, but we only know this one is the answer as opposed to the t equals 0 because we did the little extra bit, so it was necessary to actually do it out. See, sometimes in those questions I'll ask you when is the thing, and you just need to get t equals, and then sometimes they'll say like what is the maximum, and then you'd need to progress and do the second bit. And because it didn't say what was the maximum, I immediately went, oh shit, we didn't need to go that far, but we did need to go that far in order to figure out which one was the maximum. Now, you might have been able to guess in the context of that question that t equals 0 probably wasn't going to be the most amount of things they get, but a secondary way of doing that, if you had chosen to, would be to get the second derivative and sub in 0 and 15 over 8 into that. And if you remember, the second derivative giving you a minus means it's a maximum. The second derivative giving you a positive means it's a minimum. But I don't think that question really suited it, because doing the second derivative for that would have been like mind-blowingly difficult. Now, for part 3, is that part? Oh, okay, so that wasn't B at all. Okay. So it was like AI, II, and then III. Now this one gave you kind of like the graph. I'm sure if you all have it, you can kind of see the graph. I suppose you could have used that as well to kind of tell that 0 wasn't going to be the maximum. 15 over 8 would have been the maximum, because it's further down the graph than the 0. Yeah, that's kind of, yeah, they kind of, I don't mean gave it away, but you could have just said, I could tell from the graph. Do you know what I mean? Well, I don't know whether they'd allow it, but you could. So let's say it's more like this, where it trails off. You'll have to just excuse my graph. And then the y-axis goes up from here, like so. And then what they did, and I didn't really like this, they kind of split it into rectangles like this. Now again, my rectangles aren't going to be perfect. Don't go with the one in the diagram more so. And they said it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then they said this, yeah, they kind of said an overestimate can be calculated by calculating the 3 rectangles. Calculate the value of this overestimate. So basically they were kind of aiming for you to try to a weird, it's a concept that you don't really go into in Leaving Cert anymore, but it's kind of like a weird version of what's the name of it? What am I trying to say? The trapezoidal rule. But normally for the trapezoidal rule, what we do is we get like half the height, if you get me. Like we kind of find the height here and the height here and get the average of the two. But for some reason they just decided to specifically say, do it for these, like do it for mega rectangles instead of the normal. So in order to do that, you had to get the... Okay, actually, I think I misled when I was doing this with you in person. So this is, I think I'm going to answer this slightly different now that I'm reading it properly, because I don't think it really wants you to do the trapezoidal rule. It specifically mentions these 3 rectangles. Okay, like we can do it. I'll just tell whoever I said. I know who I'm talking about, so I'll let them know. Calculate the value of this overestimate. This is, hold on, I'm having a problem. Let me read this. There's some sort of ambiguity in the wording here. Let me just have a look, see, because I'll just waste your time. Yeah, it's a bit stupid the way they worded it. I thought when it says calculate the overestimate, and I just on an English basis, I didn't know whether that kind of meant calculate by how much the overestimate was, or just calculate the overestimate number in the first place. But I guess it's just calculate the overestimate number in the first place. So basically they wanted to find the area of the 3 rectangles. Now normally if we wanted to find the real amount, we'd integrate and find the area under the curve, but they want us to actually get the area of the entire rectangle, so we'd include these orange bits as well. So as you can see, it's going to be an overestimate. It's going to be too big, I guess, but that's what we're going to do. How do you find the area of a rectangle? Length by width. Now thankfully they all have a width of 3. Now the height, you'll notice this one is, the height of this is the height of the maximum. So it's a good thing we kind of found that in the last question, because we're just going to say for that rectangle we're going to do 3 multiplied by 372 point. I'm actually just not okay doing this in orange, excuse me. 3 by 372.37. That's for the first rectangle. For the second one it's also going to be 3, and for the third one it's going to be 3. But what are their heights? Well, you notice the highest point here also happens to just be m of 3, and the highest point here happens to just be m of 6. So in order to get those heights, and I'm going to pause it while I actually type it away in the calculator, but what we're going to do is we're just going to type in literally the function that we have over here, but everywhere we see t, I'm going to put a 3 initially to get the first one, and everywhere we see t, I'm going to put 6 to get the secondary one. That's all. Now, I think I pressed the button, so I don't know how fucked up that I made the recording, but I don't think it should affect things. But yeah, so basically, as I said, all I did was I subbed in 3 everywhere there's a t up here, and I've got the answer, and that's what's in here. And I subbed in 6, just because this has an x value, or a t value, I suppose, of 6. I shouldn't say an x value. And I subbed that in everywhere there's a t up here as well. And I got this number, I think. Is that right? Yeah, I think so. Yeah, I feel like I need to go back and check though, because that doesn't, I don't know why it doesn't look right. Anyway, it doesn't really matter. You'd find those 3 numbers, multiply them by 3, because remember the area of the rectangle is length by width, and they're each a width of 3. And then you'd add those 3 numbers together to find the total amount. So the overestimate is 2,272.17 blood samples. What's it say? It doesn't say round or anything, so alright. Like, you know what I mean? It's not the end of the world, I suppose, but in their leaving cert they would say, I feel like they would say to round, yeah. Now, part 4, how could the accuracy for the total number of samples be increased? The general answer they were looking for is for you to increase the number of rectangles, because if you just picked different points, let's say you said, like, let's say just even every 1 instead of every 3, you went every 1. Then what would end up happening is, now again my graph is scuffed, so don't be messing around with it too much, but instead you'd be finding the area of these rectangles instead, which fit. Now again my graph is a bit shit, but the whole message I'm trying to convey is, you'll notice these are closer to the actual graph rather than the rectangles they gave us. So the more rectangles you have, the more accurate it gets. And then another example that you could have used is to answer that question is to say use integration, because integration would have gotten you the perfect amount. And the reason why that is because they use an infinite number of rectangles, which is super accurate. So that's what that was. It goes on. Okay, I suppose it does, of course, because there's no part B yet. All right. Part B. Let's see. Let me have a look at this. Of course, it's part I. My apologies. The concentration in milligrams per litre of a medicinal drug in the blood of a patient T hours after the initial dose can be medical. Oh yeah, okay. Patients requiring this drug are said to be in a crisis if the concentration of the drug in the blood falls below 2.5. Maybe I should be laughing at that. But patient is given a dose of the drug at 9 a.m. What did it say T was? T hours after the initial dose. Okay. What was the concentration of the drug in the patient's blood immediately following this initial dose? So immediately following it, how much time has passed? 0 hours. So what they wanted to do is just sub in 0 into the original guy. Everywhere you see a T. And that's again a very common thing they'll ask you to do, but in disguise. They'll never just say sub in 0. They'll say at the start how much was it, and you just know that if that means you sub in 0. Excuse me, and then the answer would just be 4. Okay, that wasn't too bad. Part 2. If you didn't get that, I know it's going to be annoying how easy it looks afterwards. I know. What is the concentration of the drug in the patient's blood at 11:30 a.m.? Give your answer correct to 1 decimal place. Well, if it's 11:30 and it starts at 9, that's 2.5 hours. So they're just going to ask you to do 2.5. Instead. Now, thankfully, this person got it right, so I don't need to look at it, really. Correct to 1 decimal place, 3.5, apparently. Who knew? Now, again, you could do mg per litre. That's what she did. Congratulations. Part 3. Whoever's correcting it gave them a lot of ticks as well. Like, they were, like, loving life. Find the rate of change of CT at 1 p.m. What does this rate represent in the context of the question? There's a lot of questions in that we have to look at. First off, rate of change means differentiate. So in order to do that, we're going to say that CT is equal to this first off. What is it? 4e to the minus 0.05 t. Differentiate that to get the rate of change. Now, if you remember, differentiating an E like that is in the log tables. It tells you just to put the number in front of the T down in front of the E, and then write the E and the normal number and T up here like normal. And that is minus a fifth. You can do it as a decimal if you want. I just prefer it like this. Now, that is the slope formula. That's the derivative. But they said at 1 p.m. Now, I think they're trying to catch people out in the hopes that they'd sub in 1 in place of the T. But what they actually wanted you to do was to sub in 4, because that's how many hours it is after 9 a.m. So they really wanted you to do C-4 of minus 1 over 5 e to the minus 0.05 times 4. Now, hang on, I'll type that in. So I typed it all in. I just put it in, and I rendered it to 2 decimals, not because they asked us to in the question, but just because so I can say, when I'm referencing the number, I can just say minus 0.116. Yeah, she actually got it here as well. That's pretty handy. Now, what does it mean? That's what it says. So what does the rate represent in the context of the question? And that kind of means in English what's going on. And it means that the rate of change 4 hours later is minus 0.16. So that means it's changing, it's going down by 0.16 every hour at 4 hours. In 5 hours, it could be a different number. At 3 numbers, it could be a different number, and it will be. I'm just guaranteeing you. In this case, it will be, but you can't say it's going to be the same anyway. So we would say after 4 hours, it's decreasing because it's a minus number. It's decreasing by 0.16 every hour, which is a weird thing to say because obviously the rate might be different, but we still say it's decreasing at 0.16 every hour at that point, but it will be different later on. Now, what does that actually mean? Well, what is the function referencing? It's referencing the amount of drug in someone's bloodstream. So it means the amount of the drug in that person's bloodstream is decreasing by 0.16 milligrams per litre every hour after 4 hours at 1 p.m. Now, at 2 p.m., as I said, it might be a different number, but that's just what we're saying here. And that's what you'd have to say. You'd have to literally say at 1 p.m. Drug, I guess. Now, obviously, you would write this with a bit more English, but drug decreasing, and the decreasing is simply because it's a minus. If it had been a plus, it would have been increasing. Decreasing by 0.16 milligrams per litre every hour. Now, I think the biggest issue here is writing every hour at 1 p.m. And that's going to annoy people, but what we're kind of saying is that's the rate. If I just said it's losing 0.16 milligrams per litre, you'd be like, when? Like every year or every hour or every second? So that's why we have to say every hour, just to kind of tell them roughly how fast it is and tell them when that's happening. But the speed of it might be changing at different times, decreasing because it's minus excuse me, as I said. What's part 4? What is the latest time the patient can receive another dose of the drug if they are to avoid being in crisis? What did I say crisis was? Falls below 2.5. So basically, I'm assuming all part 4 is more maths though, no more fucking English. So crisis was 2.5. So basically what it's saying is when would you have to put in for T? Like what time would you have to use to get to the point where they'd slowly end up in a crisis state? What is this referencing, do you think? What type of drugs do you need to take regularly, do you think? Maybe it's someone in, to say a patient, so maybe it's, I don't know. I was just thinking in everyday life, but now I'm prying the door open to some terrible medical takes and some medical questions that I maybe shouldn't have. So we're saying, when is that going to be equal to 2.5 milligrams a litre? Because that's what they said you'd have to be in crisis mode. So we're going to say, what time will you end up in that mode? Now, instead of question mark, I know I put the question mark for emphasis. I'm going to put T, though, because that's what normal people would do. Now, I'm going to divide both sides by 4. I'm also going to just drop the kind of letters and stuff. I'm just going to focus on the numbers for this part, because I think sometimes you guys try write the units as you go, but it just makes it a very heavy kind of thing to keep track of all the little bits and pieces that don't actually get affected by the maths. So The reason why I'm dividing by 4 is so that I can get the e with the power on its own, and the reason why I wanted to do that was because if the letter you're looking for is stuck inside of a power, it would end up being, hold on, 2.5 is, why am I, that's 5 over 2, Jesus Christ, 5 over 8 then. Yeah, so yeah, but I wanted it to be like this because if ever the letter is stuck inside of a power, we have to resort to the top right of page 21. I think I said it earlier when I was doing the other log questions that it was going to come into it the opposite way around. So we go to top right of page 21, but this time, and I've cleared the board, I don't think I have it. If I, let's, nope. So basically, it says that if you have a to the power of x equals y, I think for the letters, then it has the double arrow thing, and then it would have log base a of y equals x. I think those are the right letters. It's the right way round, but the letters might be different. I can't recall which way around it is, but I'm just going to say then this is my a, this is my x, and this is my y. So then if we rewrite it out in the opposite fashion, I would get log base e 5 over 8 equals minus 0.05 t. And then to get t on its own, I would divide both sides by minus 0.05. And that should tell us the time when you end up in crisis, which would be the time when you should probably get another injection, so that you don't end up staying in crisis. Hang on, I'll type it all in. Okay, so that's what happens when I typed it all in. Sorry, this girl, I just realized I'd written it down, but I didn't get full marks. Alright, it's... I don't know how... Again, this is something that they'd be more specific about in the Leaving Cert. I don't know how serious they want to take it. So it's 9.4. But don't forget, that's not the final answer, because that's not what is t. They're saying what is the time. And we know it starts at 9. So it would be... We'd have to go to 6 p.m., but we'd still have 0.4 of an hour to kind of deal with. So the 9 here takes us from 9 a.m. to 6 p.m., but we still have 0.4 of an hour. Now, if you want to find out how many minutes that is, you just do 60 multiplied by 0.4, and I think it should be 24. So it should be 24 minutes. So instead of this, we can say 6:24 p.m. Again, I don't know how specific they wanted to get with that. In the Leaving Cert, they might say what hour would you need to get it done in which case you'd say in the 10th hour afterwards, because for the first 9 it was fine, and then it was in the 0.4 of the next one is when you get into crisis mode. They didn't really specify that here, that's why I don't really like it. Yeah, so that's just one point I wanted to make, but I think it's like 6:24 would be the answer there, unless I'm missing something, which I might be, because I don't know, I thought I was fine, and you notice I made a couple of mistakes, so, you know. By all means check this shit, make sure I'm on the ball. Another point I want to make while we're here, this isn't part of the question, this is just me saying log base e with the big number in the box here, don't forget it's the same as ln with the number in the box here. So if I put a 3 in here, it's like putting a 3 in here. So up here when we did ln or log of 5 over 8, you could have done ln instead if you wanted to, but there's no rule that says you have to. It's just in case you prefer to, or in case you did do it and you are thinking that you were wrong. Yeah, I'm gonna take a break here. Okay, gonna try finish this off now, right? So question 9. Yeah, now I didn't really like how question 9 was framed, in all honesty, because normally in the Leaving Cert they wouldn't give you 4 options at the start, because let's say you get that wrong, then the rest of your questions are all just going to be scuppered, so they probably wouldn't do that. They probably just give you the correct one at the start. But yeah, it talks about how in a laboratory experiment the population of particular bacteria began with 500 present. The population grew at a rate of 45% each week, where P is the number of bacteria and T is the number of weeks. Whoops, I'm after liking it or something, so that person's going to get that from the start of the experiment. Now, not something that's really done a huge amount in school with you, but every exponential formula can be written in the form of like a b to the power of t, we'll say. Now t can be in the place of x. where A is the amount you start with, B is the amount you grow by, so we sometimes call it growth or scale factor, and then T is the amount of times that the growth occurs. So let's say there were 2 bunny rabbits, and each year they tripled the population, and then after 6 years, what's the population? That's what we would do there. We would figure that out. 81, 700, not that you need to do that, right? But that's just what they would do, right? So here, because we're starting with 500, the number should be 500. Now, they said it's increasing by 45%. What you have to remember is that doesn't mean you put 45% here, right? That's not correct, because that just finds out what the increase is. It doesn't add it to it, right? So we have to kind of amend that slightly to account for that. Also, we wouldn't write 145% either, because in maths we would use decimals instead of percentages, but that is more correct because that is doing 100% and add 45% as well, which is what increasing by 45% is. It's kind of do the 100%, the original 100%, and then add on 45 as well. So we would use the decimal version though. We would use 1.45. Because if you multiply by 1, you'll get 500. If you multiply by 0.45, you get 45%. If you multiply by 1.45, you will get 145%. And then we just have to put a power of t to kind of signify how many hours, days, what was it? The number t is the number of weeks, right? So if it increases by 45% each week, then after 3 weeks, it will have been increased by 1.45, a factor of 1.45 3 times. So we put t to the power of 3. And another reason why I didn't like this question is because you notice that's the first one on your page. So that is a correct... Oh, heavens, excuse me. That is a correct answer. But in the same way that you could do, like, let's say you had x to the power of 6, but you could change that into x to the power of 5 and just another x, or x to the power of 4 and x squared. You know what I mean? You could break it up into different things. They also kind of said here that you could technically also break this up into, and I'm doing it in different color pens so you can kind of see it's just a break, it's a different thing. They broke it up into 1.45 to the power of 1 and 1.45 to the power of t minus 1, because they took 1 out of this and put it here, but then obviously this power is 1, has been taken out, so it's 1 less than t. And when you do that, it gets you the 725 number. So 725, 1.45 to the power of t minus 1 is also a correct way of doing it. And I didn't like that there was 2 answers. It was the first and the third one worked. All right, that's the first and the third one. I know I haven't really written it out correctly, but that's what the answer is. The first and the third one. What is this? 9AI. Yep, first and the third one. The second one doesn't work because it's doing the 500 by 0.45 each time. And all that would be doing would be finding 45% of it each time. So if you did that, it would actually, the number would keep getting smaller and smaller and smaller instead of increasing. And then the other one is the 725 by 1.45 t plus 1. But what that would imply, because it's t plus 1 instead of t minus 1, they're saying that the 1.45 in 3 weeks, like let's say it's in 3 weeks, we're supposed to have increased it by 45% 3 times. But if you put 3 in here, it obviously becomes 4, which would imply that the 1.45 was applied 4 times in 3 weeks. So that's wrong as well. That's why that's wrong as well. Not a huge deal, but just both of them are the incorrect ones. As I said, I don't like that they gave you multiple choice. I don't like that even when they gave you multiple choice, there was 2 correct answers, 2 suitable ones. It's just, I don't really like it. But let's go on anyway to the things that are more, I'm not going to say actual maths, but the more relevant stuff. So for part 2, like things that are more likely to come up in your leaving cert, calculate the population of the bacteria after 3 weeks. Give your answer to the nearest whole number. Now this is why you guys can't see what I'm looking at. I'm looking at it on my phone. This is why I don't like it. This person in the first question picked the wrong formula, which is fair. Out of the 4, she picked the wrong one, which is completely understandable because it's a shit way of doing it. But she did the correct thing, because in this, after 3 weeks, you're supposed to sub 3 in place of the t. So I'm going to pick this one, but I could just as easily have picked this one, because as I said earlier, they were both right. But whichever one of those I pick, I will get the right answer. So if I do, and you can check that yourself if you're just kind of curious how this works. If you do this, the power of 3, Or alternatively, if you did this one to the power, now the power here would be 3 but minus 1 because it's t minus 1. They would both get you the correct answer. Now the girl actually did sub in 3 but into the formula that she picked wrong, and they docked her for that. I don't think that's right though, but I'll talk to her about that, not you guys. Hang on, I'll put that in my calculator now. So then that's the number you get, 1524 but it says the nearest whole number, so I just round to the nearest whole number. And just again, I suppose it kind of helps to explain why that's the one with the 0.45 is wrong, is when she did it with the 3, and I will say I think in my mind she should get full marks for what she's done, the way the marking scheme works, but her answer was 46, which obviously wouldn't really make sense because the population is supposed to be decreasing. So if you see a situation like that, you can kind of think about it with your, not common sense, because it's not common sense, but like kind of think about it and go, well, it going down to 46 doesn't really make sense, so maybe I'll try something else. If time constraints don't allow it though, by all means just throw something down and move on with your life, but if you can. During which week did the population of bacteria first reach 2,100? Again, I think she should have gotten full marks for what I've seen her do there. I'm going to have to talk to her. As I said, I'm after accidentally like doing the prayer emoji on it, so like, or high five emoji. I don't know what you guys would consider that as young people. But during which week did the population of bacteria first reach 2,100? So, instead of subbing in for T, we're trying to figure out what we need to sub in for T to get 2,005 or 2,100 as an answer. So I'm going to equate it to 2,100 because that's what I want to happen. I put in 3 there. My apologies. That should be a T. But I want to figure out what I'm putting in for T instead of 3 this time. That instead of getting 1,524, I'm going to get 2,100. You could keep guessing values for T, but that's stupid. It would make you look stupid. You get a lot of decimals, and also in the marking scheme, sometimes they will say if they do it this way, the most they can get is 3 out of 10. So try avoid it if you can. What we're going to do is we're going to keep getting rid of the things that aren't T, the things that are furthest away from the T. So I'm going to do 500 here on both sides. And as I said, we're trying to get rid of things that are furthest away from the T, but also the reason why I'm doing that is because you notice the letter we're looking for is stuck inside of a power, and if I want to save him, if I want to rescue the guy that's stuck inside of the power, we have to use the top right of page 21, the logs nonsense again. Now I definitely don't have that still open, so I'm just going to write it here. I think again I have the letters the right way around. If I don't, I don't. That's okay. It doesn't really matter. It's the same idea though. So down here, I would identify this is my A, this is my X, and this is my Y. I'm going to whip it around and do it in the other version now, because then we'd end up with log of 1.45 of 21 over 5 is equal to T. And you'll notice now, as long as we just type that in, I'm going to do that now. Hang on. Yep, if you type it in, then you'll notice you just find out what T is equal to. Now, maybe you guys might prefer it actually if I kept it in line. So, sorry, the 3.86 will be on this side, and then the T is here. Sorry. But yeah, so you'll notice that it was super handy then that the logs kind of made it so that everything on the left we could just throw in the calculator. Keep in mind, again, generally when you guys are doing logs, you're going to use the button on your calculator as the boxes, just in case you didn't know that. It looks like that, and you put 1.45 in the small one, 21 over 5 in the big one, and it's just equal to T, and it's horrendous, but the calculator's doing the horrendous part for you. You're just kind of rearranging it into a horrendous fashion, and then the calculator's just doing it. So like, you don't need to worry about it too much. Now it does say during which week did the population reach 2,100. So our very final answer would have to be in the 4th week. Because it's 3.86. Now, you might say, well, I could have told that because I can just round 3.86 and it become 4. But let's say we did this question and the answer had been 3.12. That's still in the 4th week. Because after you go past the 3, the first 3 weeks are already finished. So 3 point anything automatically implies the 4th week, even though rounding 3.12 would go to 3. We're not talking about rounding, we're talking about in real life. You're 0.12 of the way into the 4th week, so that's why the answer there would be the 4th one. And then I skipped a page. After 8 weeks, now this was a fucking doozy. After 8 weeks, the growth rate slowed to 20% each week. How many weeks in total did it take for the population to reach 35,000? There's a couple of ways of doing this one. A couple of ways. I'm going to do the way that is most obvious to me, I feel like. Let me just say B. Yeah, it's just B. So what I would have done is, I would have said, it says after 8 weeks. Okay, after 8 weeks something changes. Before I even do that then, what I'm going to do is, I'm going to figure out what is the population after 8 weeks. So what I would have done is, I would have done 500 by 1.45 to the power of 8. And that's basically telling me if it starts at 500 and goes 8 weeks this way, the number over here, again I'm going to pause it while I type this in to save time. So there was a bit of decimals on that, and to be honest, if I was doing my own leaving cert, I would have left all those decimals in it, but just to avoid clutter on the page, because obviously you guys are looking at this, I can see maybe I should have kind of split these up a bit more, but just to avoid the clutter and to avoid the complications, I'm just going to explain like the concept of the question without having like 0.4430 or something at the end of it. So what I found now is, at the end of, it says at the end of the first 8 weeks, and I was like, well, hold up, I need to know what's going on at the end of the first 8 weeks. If you're going to change shit, let me just catch up there first. So I found out how many bacteria there are after 800 weeks, or 8 weeks, sorry, and it's 9,770. Now, they tell us now that it changes. So the growth rate has slowed to only 20% each week. So that means that each week we're going to multiply by 1.20 if you want to, but 1.2 would also work. And the reason is don't forget that if you did 9,770 by 20%, the maths way of doing that would be 977 by 0.2. But that would only find you the increase. That's not going added on for you. Like if you do that, it will tell you some number like 1,800 and 1,900 and something. But if you do 9,770 by 1.2, it will take the extra bit, the 0.2, and add it on to the 9,770. So that means every subsequent week, every week that's about to happen after the 8 weeks, we're not multiplying by 1.45 anymore, because that's the old growth rate. We're multiplying by 1.2 because that's the new growth rate. So, now, here's the thing. It says how many weeks did it take for it to get to 35,000. What you could do is you could just do 9,770 by 1.2, get an answer, and if that's not 35,000, just do it again, and keep track, right? So if you multiply by 1.2 once, that will get you to the end of week 9. Is that 35,000? No. Well, then I do it again. That will get me to the end of week 10. Is that 35,000? No. And then we just do it again and again and again until you get there. What I would do, though, is I would say, and this is going to be tricky, right? So you might need to look at this a few times or even ask me, right? So what I would do is, in person, I would say 9,770 multiplied by 1.2. Now, how many times is it going to be? Well, let's say I want it to be, let's say it's going to be 3 more times. The lines aren't parallel, it's annoying me. Let's say I want an extra 3 weeks at the new rate. The problem is that's week 11, because it's the original 8 and 3 more. But I only want the 1.2 to have happened 3 times, because we only want 3 weeks at the new rate. So I can't put t here, because if I put t there, I'd have to sub in 11, right? So that's problematic. Now again, there's another way of doing this, so if you had thought of doing it a different way, it might be right. I'll try mention that as well. This is just a very complex thing, and I'm afraid if I mention multiple ways, they're all just going to mingle and just get super confusing. What I would have done, though, is I would have said, I can't put t here, because then I'd just be putting 11 in, even though I really only want to be putting in 3. So what I would do is I'd say t minus 8, because what that's doing is it's saying, well, what week are we in? Oh, week 11? Well, the first 8 weeks we already took care of when we got up until the 9,770 number, so they're dead to us, so we're just going to ignore them. So we're going to take them away from the 11. So now if we put 11 in for the t, it would tell us what it is at the end of the 3 extra weeks, or overall at the end of week 11. Now, keep in mind, I just picked the number 11 randomly. That is not the answer to the question. That isn't just me trying to explain to you why I did t minus 8. So I picked actual numbers so it would make sense. So that's what the formula is. I would say at the end of week 8, you start with 9,770. We're going to multiply by 1.2 each time because it was an increase of 20%, and we need to have the 1 as well. And we can't put t because then we'd be putting 11, which would mean the 1.2 increase, the 20% increase, has happened 11 times, but it hasn't. It's only happened 3 times. So that's why we have to do the 8. If I picked 12 weeks, like if I picked week 12, then the gap would have been 4 weeks. But if we put 12 in here, it would be 12 minus 8, which is 4. So it all does make sense, like if we were to do it for other ones as well. Hopefully that's okay. I don't know how much more to go into it. I'm afraid sometimes in my head that people wouldn't get that. You guys can rewind it, and as I said, ask me, I suppose, anyway. Maybe I need to clarify it a bit more, but I kind of don't know what to clarify, and I'm afraid if I keep talking about it, I'm just going to make it more and more confusing. So I'm just going to kind of stop trying to explain that, and I'm just going to finish answering the question for now anyway. So we want to find out when it reaches 35,000. So basically I'm just going to put this formula equals to 35,000, and this will basically be, remember when I said just keep guessing, or just keep adding on a new week until you get there? This is me doing the what number would I have to sub in for t to get there without having to do them all one after the other. I'm just going to use maths. Yeah, because we're starting with 9770 and we're hoping to end up with 35,000. So that's what I'm doing here. Now we'd have to divide both sides. I'm going to try to use the same colors as I did in the version above so that you can kind of see similarities between the two of them. So 9770 here and 9770 here. That cancels. We're left with 1.2. Do you see where we're going? Do you see where we're heading with this? I know I'm excited too. I don't think that divides 35,000 divided by 9770. Yeah, no, not really. We just say 3,500 over 977. But that's a 7, I promise. But the power we're looking for, or the letter we're looking for, is stuck inside of a power, because the t is stuck inside of the power on the 1.2. So we're going to use our log thing again from the very top. Now I'm not going to scroll back up if that's okay with you. You guys can if you want, or hopefully have your log tables with you, or you just have learned the formula off like a good little person. Now we have log of 1.2 bracket 3,500,977 equals, now this time it's going to be equals to t minus 8. Don't forget that this was t minus 8, not just t, right? And then we slap that into the log, or into the, well, not into the log, but into the calculator. Hopefully you're all okay with how to use the log button. If you have one of the new shit calculators, I'm assuming it's all still the same. I think they just hide the other ones. Now I end up getting like 6.998 blah blah blah. I'm just going to say 7, to be honest with you. And then I add 8 to both sides, or bring this over here and make it a plus 8, and we end up with 15 equals t. So basically, let me just check the wording again of the question, but basically it's the 15th week. How many weeks in total did it take for the population to reach 35,000? I would say 15. Damn near exactly. Like it's 6.999, whatever the hell. But I would say week 15 exactly. And that's the final answer to that bit, in my opinion. Let me just make sure exactly. It says, yeah, after 8 weeks, how many weeks in total did it take for the population? Yeah, so 15. So it was 7 extra weeks on top of the original 8 weeks to get to 35,000. Now, so that's the answer. If I'm about to do I'm going to talk about a different variation of this part. So if you're okay with what I just did and you don't want me to confuse the issue, you can just kind of zone out until I start part C or whatever. But what another way of doing this would be is, if over here, I'm going to do it over here. You said 9770, because that's still the amount you're starting with, and you did 1.2 to the power of t. What's happening there is, in this situation, it's kind of like you were one of the scientists who was on holidays for the first 8 weeks, so you had no idea that any of this here happened. If you just do t, you're assuming that this is 0 weeks. So instead of 11, this would be 3. And what you're going to say is then, you'd do the exact same thing. You'd basically do the exact same thing. You'd put that equal to 35,000, right? But you have to remember that whatever answer you get for T, there were 8 weeks where the other scientists were doing shit without you there, right? So whatever answer you get, you would have to add 8 on yourself to get the total amount. Now, firstly, understanding that is difficult, but secondly, even let's say you get, and I promise you, if you do all of this shit down here, I'm not going to do it, but if you do it all, you'd end up with 7 equals T. And you'd go, oh, happy days, the answer's 7. You might even just forget, because you'd have done all, like, look at all this shit, you'd have done all of this type of nonsense. And then at the very end, you have to remind yourself, oh, and don't forget, the other scientists were in the lab for another 8 weeks, so in total, it would be this number. But that's an alternative way of doing it. I just don't know if people would really enjoy that or not, but I just feel like the need is there for me to say, cover as much different ways as possible, and to show you is that I'm always afraid as well, I'm going to answer a question in a way that I would answer it, in the way that I think is the best way, and then you're going to have answered it your own way, but then gone, well, Graham's better at maths, so therefore he's probably right and I'm wrong, where it might be true, but it might also be that you have an idea as well that might be correct. And I'd say there's a couple of you who think you are better at maths than me, so that's a different issue. But see, what constant weekly growth rate would produce the same change in population from 500 to 35,000 in the same time as found in Part B? So what they're saying is, they're still talking about this science, this lab nonsense. So they're saying in the last one we found out that from 8 weeks, for the first 8 weeks we went from 500 to 9770. And that was when the 45% increase was happening. But then there was a second section where, and we have found it afterwards, now we know it's 7 more weeks. We know after 7 weeks it went up to 35,000. But that was that 20% increase. They're saying, what equivalent would we have to be so that we would go straight from 500 to the 35,000, no stops? So it's still 500 and it's still 35,000 at the end, but instead of 2 different percentages, they want 1% the whole way. And that's what they're asking you for here. Because they're saying, what constant weekly growth rate? So what weekly growth rate could you have that doesn't change this time? That's what the constant means. But it would produce the same change in population from 500 to 35,000 in the same time. So what we're going to do is, we're just going to set up the formula where we're going to say it's going to be 500, because as we said, anything where it's increasing exponentially is going to be the initial amount multiplied by the growth factor, or growth scale, growth, whatever. There's all sorts of different words that we use there. But it's this guy is what I'm looking for right now. I'm not going to write it like that. Sorry, vouchers. I'm going to just write it as a big fat X. And we're going to move on with our lives. For the moment, we're going to figure out what that is, and we'll talk about the answer as well. There's still some kind of connection we have to talk about as well. And then the amount of times that we want that to happen. But if we want to happen from the 500 to 35,000, that's the same as the 8 and the 7. So that's 15 weeks in total. So we want it to be 500 at the start. We want it to be 15 weeks of the same growth rate. And we want to end up with 35,000. Now here, we won't need to do logs, thankfully, because the power we're looking for, or the letter we're looking for, isn't stuck in the power. It's over here. So we're going to have to do some maths to get that. But it's not logs. So congratulations. We're going to divide everything by 500. Just because we don't want the number in front. It'd be a lot easier for us to be able to deal with this. Like, we're going to have x to the 15 is equal to 70. Now, how do you deal with this? If you had x squared equals 16, you would change it to x is equal to the square root of 16, which is 4. Here, what we're going to do is we're going to change it to x is equal to the 15th root of 70, which isn't obviously ideal, but there is a button for that on your calculator. The different calculators are going to have different ways of writing it, but for mine, it's like in the middle at the kind of the top, and it's in like orange or yellow or whatever color you want to say. One girl said that was green one year. I don't know. 1.32, like, there's a little button that looks like this, as a box here, and it's shaded in on my calculator. I don't know if that's true for all of them. And then an empty box here, and you just put 15 in the small box. But there's 1.327414435. Who cares? And don't forget, this isn't actually part of the answer. That was just me explaining to you guys how to do the root part. Now, it says, what was the constant weekly growth rate The thing is, we can't, that's not our answer. Because what we're doing there is we're saying that we needed to, now it says correct to one decimal place first off, actually. I'm not going to do that actually, because that's misleading. I'm going to explain that as well. Okay, hold on, I have to keep track of this. So what we're saying x is this, we're saying we should have done 500 by 1.3274 yada 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 to the power of 15 to give us 35,000. Which is correct, but this guy here, don't forget, is the 1 plus the growth rate. Because remember, the 1 is to account for the 500 that already exist, and the 0.3274 is to account for the increase. So actually, the growth rate is 0.3274. But they say give your answer as a percentage, so we'd have to multiply that by 100 because to make it a percentage, which would be 32.74%. And now rounding that to one decimal place would be 32.7%. Now that's why I didn't round it up here. You'll notice if I just rounded it up here to 1.3, and then down here this would be 0.3, then multiply that by 100, it would just be 30. Which, you know, is too rough, too vague, you know what I mean? It's not specific enough. So yeah, I would say that it would have to be 32.7% for the 15 weeks in order for it to get to the same amount. And that kind of makes sense because it's in between the two guys that it was, you know what I mean? If they did 45 and then 20, kind of makes sense that you'd get a number between the two of them for the entire 15 weeks. Now you can't just add them and divide by 2, or you can't just find the average, or you can't, you know what I mean? You have to do something like that. But yeah, that's how you'd answer that one. Is there anything else I meant to say? I think I hit all the things that I said, because there was a few things in a row where I was like, I need to say this, this, and this about it. Hopefully that's okay. I'm aware it kind of looks messy now that I look back at it. You know what I mean? Like, I'm keeping track of it while I'm doing it. But then when I like kind of take a step back and look at it, I'm like, yeah, I can see you guys might be a bit disturbed by the shambles of it all. Once the bacteria population reached 35,000, it began to die out at a rate of 250 each day. Approximately how many weeks did it take for bacteria to die out completely? Now, this is the thing where we're not going to do a new formula for this because it's not 250%. It's not a percentage change. 250 is just literally each day. So like you could say 35,000 is the first day, and the second day you'd have to take away 250, and that would be 34,750, and then we could take away 250 again, and we get 34,500, and just keep doing that until you get to 0 and count how many times you took away 2,500. Instead of doing that though, we're just going to say, well, how many times could we take away 250 from that before we get left with 0? And another way of doing that is just dividing it by 250. 4 of them is 1,000. 140? Yeah, 140. So that would be 140 days, keep in mind. And to find out how many weeks that is, you'd have to divide that by 7, so 20 weeks. So this was different, that it wasn't decreasing by a percentage each time, it was decreasing by a flat number or a constant number of 240 each time, or 250 each time, sorry. So when you divide by 250, you're finding out how many times can you take away 250 from that number before you're left with 0. And then just remember they asked specifically for weeks, not days, so you'd have to change that around. Hopefully you all know how many days there are in a week. Some of you guys, I have my doubts. E is a weird one because it was nothing to do really. Like it mentions, oh, it's still a laboratory, but it wasn't the same. So 0.42 with the dots on the 4 and the 2. For any of you that do not know, means that the 4 and the 2 get repeated forever at the end of that decimal, right? They just go on forever and ever and ever. Yeah, and it's hard to see the dots in your calculator sometimes, but just check and they are there. So it says use the formula for the sum to infinity of a geometric series, which is on page 22 of your log tables, I think. I got one of them wrong the other day, so it's just kind of triggering me slightly in that regard. And show that it can be written as 14 over 33. So there's a trick to these questions, right? If you remember, A is the first term of the sequence, like a sequence, a list of numbers, and OR is what you're multiplying by each time, and we call that the ratio, what we're multiplying by each time. So what we do is we take the big ass decimal up here and we change it to 0.42 plus 0.0042 plus 0.000042, and it would just keep going on forever and ever and ever. Right, so we're just decomposing it, which, you know, if you added all those together, you would get back to that. You're kind of just breaking it down into like the copy and paste sections, these parts that are the same each time. And the reason we're doing that is because you'll notice this is our first term, so this is a. Right, so that's what we're going to put in for a in this formula. Now to figure out what OR is, to figure out what we're multiplying by each time, we need to do the second one divided by the first one. If you recall, this type of thing is true for a geometric series anyway. So what that means is we should be able to do the second one divided by the first one, or the third one divided by the second one, to figure out what we multiply. Because this way, what we're saying is we multiplied by something to get from 0.42 to 0.0042. If we want to go backwards, we're going to have to divide by that same something. Basically is kind of what we're saying, right? So we're going backwards, so we have to do division, because normally going forwards we do multiplication, basically. So what we would do is we do 0. Maybe make more sense when I have all the numbers written out. 0.042, you know what I mean. If you do that on your calculator, I'm pretty sure it tells you 1 over 100. And if you had done the T3 divided by T2, if you'd done the third one divided by the second one, I guarantee you, well, at least it should have worked out the same. I can't guarantee you, because you might have typed something into the calculator wrong. So, OR is flat out 1 over 100. Because now you could have used this one as well, like they're both the same thing, because it's the same ratio each time. And all you do is you just slap that into the formula there. So we'd end up with 0.42 over 1 minus 1 over 100. And I promise you that just does work. I'm not going to type that in, but that does end up giving you the 14 over 33. I've done it before with some people, but I'm not going to type it in just to save time, if that's okay with you nerds. So, hopefully that makes sense. Question 10. You guys were all giving out about question 10, about some French guy looking at you. What were the waves? What do they mean? What's going on? Weirdly, if I remember correctly, in this question, you don't really need the graphs. I think the very last one you might need to be mentioned. Jean-Baptiste Joseph Fourier was a French mathematician who explored how non-trigonometric functions can be modeled by the sum of trigonometric functions. Below is a sequence of graphs which becomes progressively more triangular as additional terms are added. Each function has an associated k value, where k represents the number of terms in the function. So for the first one, fx, it says k is equal to 2, and that makes sense because it's 2 terms, sine of x and sine of 2x over 2. The third one is k equals 3, and that makes sense because sine of x, sine of 2x over 2, sine of 3x over 3. Same with the fourth one. And you'll notice the signs alternate each time. So it starts off with a plus sine x in all of them, and then the second one is always a minus, and the third one is a plus, and the fourth one is a minus, and it would just keep alternating like that. Now, let's see. Find f dash x. 10a I is find f dash x. So f, let me just go back. I think I know it, but I don't want to fuck it up. Fx is equal to sine of x minus sine of 2x over 2. Now, just one thing, for the love of God, you cannot cancel those 2's. The 2 on the top of the fraction is stuck inside of sine jail. You cannot go near him, right? You can visit, you can't go into the jail cell with them. Now, if we want to differentiate this, what we'd do is we'd go to our log tables and we'd notice that sine, or sin, you guys pronounce it however you want, turns into cos of x. Now, the thing about the sin 2x nonsense, right? So, I think sine turns into cos of x. It's either cos or minus cos, but I'm pretty sure it's cos. But there is an extra rule that you guys need to know in leaving cert level. If you're differentiating sine of ax, now I believe this should be in the log tables, but it's not. If you're differentiating sine of, let me do this one first. If you're differentiating sine of x, it turns into cos x. That's just in your log tables. This next one here is not. If you're doing sine of ax, it turns into a cos ax. Same with if you were doing cos of ax, it turns into minus sine, and I think again I have this the right way around. Sorry, minus a sine ax. So basically, if there's a number and x inside of the thing that you're differentiating, inside of the trigonometric ratio that you're differentiating, that number just gets slapped in front, and you differentiate the sin or the cos or the tan, as we saw earlier with the 5x, like normal. So if I was to do sine of 2x and differentiate that, that would turn into 2 cos 2x. So the 2 gets slapped at the front, and then sine turns into cos. And technically that's the chain rule, but you don't have to do it. They will just trust you that you're like, this is what it is, and they'll say, okay. So if I differentiate the sine of 2x, it will turn into, or sine of 2x will turn into 2 cos 2x. Again, ask me about that in person, because that is an important thing that people overlook a lot. The over 2, you notice the 2 on the bottom of the fraction I haven't touched, because that is a constant. That has nothing to do with x. Well, like, we're going to divide it and all sorts of nonsense, but what I mean is we wouldn't have to use the quotient rule there because there's no x on the bottom. If you want to, technically, you could change sine of 2x over 2 into 1 over 2 sine 2x before you differentiate. Just literally just rearranging it. Those two things are the same thing, the exact same thing. And then you notice it's just a number in front of the thing that you're actually differentiating. So you differentiate that and just have the half in front. You could do it that way as well if you wanted to. I wouldn't. But if you did, you'd end up with a half 2 cos 2x. You'd have like that instead of this. I don't know if people prefer. You can go whatever you want. I just prefer this one. Maybe there's no reason for that. Maybe I'm just being peculiar. But I like this because now I can see that the 2's cancel out. And that 2 is not in cos jail. So, hallelujah. It's freedom time or something. I don't know. He's on day release. There's some joke there that I've never actually run into before, so it's not good. But we'd end up with this. And we cannot progress with that any further. We have to just leave that the way it is. That's just the end of it. Cos x minus cos 2x. Your final answer for part I. Hopefully that's not too mad. That's not too confusing, because a lot of the next questions kind of rely on those assumptions that we're going to be dealing with again and again. I'll try to explain them when they come up, but we'll see. It says show that f dash pi is equal to this. Well, we're going to do cos of pi, and then we're going to do minus cos of 2 pi, and you can literally just do that in your calculator. Cos of pi turns into minus 1. There's a minus from this, and cos of 2 pi turns into a plus 1. But there's a minus from the formula, so we end up with minus 2. Wasn't that fun? Let me just cos of pi. Cos is the width. Yep. Yup. I didn't like this question. It's kind of repetitive. I know you guys say it's difficult. It is difficult to look at, but the actual, if you get into the nitty-gritty of the maths, it's actually just kind of repetitive, because you notice gx is equal to sine x minus sine 2x over 2 plus sine of 3x over 3. And they ask you in part 3 here to differentiate it again. Find g of dash of x. We've already done the first two up here, so I can just repeat that. That's fine. I already know they turn into these two things. So cos x minus cos 2x. Now this guy, in the same way over here, if I differentiate sine of 3x, so using it now, I'm referencing the rainbow bit here, just so you know where I'm at, right? If I just follow that kind of same pattern, I'm going to whip the 3 in front. It's going to be a 3, and the sine turns into a cos, but there's still a 3x in there. So this will turn into 3 cos 3x over 3. And then these 3's cancel because they're on parole. I don't know. I didn't have enough time to come up with one. Don't judge me. So we'd end up with cos x minus cos 2x plus cos of 3x, right? And that's where it's going. And then for part 4, it says to find h dash x. Just writing it out is going to be a pain in the hole, that's all. Sine of x minus sine of 2x over 2. Sine of 3x over 3. You'll notice all of this so far is just gx, and then the only little addendum we have to make for when k is 4 is just there's going to be a minus sine of 4x over 4. differentiate it again. We've already done the first three in G, like in part 3 when we differentiated G. So it's going to be just those answers again, cos x minus cos 2x. Now at this point you can probably tell the pattern, and this is why I didn't like the repetitive nature of it. They wouldn't do this in the Leaving Cert, because if you can get this, you can get all of these questions. If you can't get it, you get 0. And they don't really like that kind of methodology in the real thing. I don't think so, anyway. But here, if we did sine of 4x, we have the 4 in front, with 4, sine becomes a cos, we're left with 4x here. We'd end up with minus 4 cos 4x over 4, and the 4's cancel. And we're left with cos of x minus cos of 2x plus cos of 3x minus cos of 4x. Now, v, hence fill in the following table. Yeah, no, this. Sorry, I was looking at what she wrote again. She wrote all the right answers. How she figured that out? Maybe she just spotted the pattern. Is that all you did? Spotted the pattern. Maybe. But basically, we already know f dash of pi is minus 2. So we already have that answer from up here, right? So that's the first one. That would go in the first box. Technically, if we were to do this properly, we'd say g dash of pi, or g dash of pi is equal to cos of pi minus. Now, I think this is written by someone from, I don't want to say the older times, but someone who doesn't know how the modern calculator, not doesn't know how it works, but just isn't as connected with it, because I feel like they asked this with the intention that you'd have to try to figure this out yourself using your brains. But none of you guys have brains, you have a calculator. So you would say cos pi, put it in my calculator, get minus 1. I should point out, I didn't say this at the start. I'm realizing on my comment that you don't have brains. You guys might have not remembered to put your calculator into radians first. So if there's a pi inside of a sine or a cos, it's always assumed that you're dealing in radians. My apologies for not thinking to mention that at the start of this question, but as soon as there's a pi in there, you have to do it. I don't know if they mentioned it. They didn't mention it anywhere, I don't think, right? No, it's just automatically assumed if there's a pi inside of a sine or cos, you want to put it into radians mode. My apologies if I didn't get that across to you in time. Cos pi, though, if you put it into your calculator in radians mode, you get minus 1. There's a minus here. Cos of 2 pi, if you put that in your calculator, is just 1. There's a plus here, and cos of 3 pi, if you put it in your calculator, is minus 1. And if you do all that, you get minus 3. H dash pi, in the same manner, be cos of pi, oh my god, minus cos of 2 pi plus cos of 3 pi minus cos of 4 pi. And then you'd say this is minus 1, this is minus plus 1, this is plus minus 1, this is minus plus 1. And that's minus 4. So the thing is, basically it repeats, right? So basically this one and this one are minus 1s. This one and this one are plus 1s. Now the reason why they're minus is because both of them have a minus at the start. But if you put in just the cos 2 pi or just cos 4 pi into your calculator, it would say plus 1. So basically what it is you'll notice that the orange ones, the ones I've circled in orange, if the number in front of the pi is even, the answer will be a plus 1. But because of how they set up the function, it will already always have a minus in front of the orange circle as well. So even though the answer would be plus 1, the minus will turn it into a minus 1. And then the even, or the blue ones will all have an odd number in front of the pi. And as a result, they will all give you minus 1 as an answer. And they already all have a plus in front of them. So it would still be minus 1. So regardless of which one you get here, you'd always end up with them all being equal to minus 1. It's either going to be a minus 1 on its own, or it's going to be a plus 1 that had a minus in front of it in the function. So that's what the kind of pattern is they're hoping you'd spot, and they do make reference to it in the next few questions somehow, but I just wanted to kind of get that across while I was here. V part I, explain what now? Explain the effect of increasing the number of terms, i.e. increasing k from 2 to 3 to 4 on the slope of the tangent of each graph at x equals 4. So basically, see, I didn't know how they wanted you to write this, because in one of the next answers, I kind of come across the same answer I'd give for this one. But basically, you'll notice that the slope is always equal to minus k, right? Whatever k is. So in the first one, for fxk was 2 because there was 2 terms. For hxk was 3 because there were 3 terms. And g was 2. H was 4. And that's just based on what they told you on the first page, what they told you k was. So basically the idea is, as you increase the k, if you follow me, as you increase k, the slope decreases. It gets even steeper, right? Because a minus means it's going down slope wise, but a bigger number after the minus means it's even closer to a straight line, whereas a smaller number makes it like less slanty, if you know what I mean. That's not going to become a straight line for some reason, so we're just going to live with that. Yeah. But yeah, so basically what they're saying is, what happens, and you'd say as k increases, the slope gets steeper and steeper, but it's still going down because it's still a minus number regardless, because as I said, they'll all be minus ones. How they actually wanted you to answer that, I'm not entirely sure, because you notice it's just a bit vague, kind of how they left it, to be honest, from a maths person's point of view. Maybe they if I was talking to them, they'd say it, and I'd be like, oh yes, of course, but that's my opinion in this moment. Now, part B, let px be the function of this type with k terms where k is any positive integer. The general form of px is therefore this. Now, I'm not going to write all of that out. Hopefully you have the exam in front of you, but basically if you don't, it says px is like fx and gx and hx, except it just keeps going. It doesn't just stop at 1 or 2 or 3 or 4. It has the first 7. So it starts with sine x, goes to sine 7x over 7, plus ... and then the last one it says is plus minus 1 to the power of k minus 1 sine of kx over x. Now this thing, you'll notice, is just what all of these guys have been so far. They've all just been sine of a number x over the x. I've written it down wrong, over the k, sorry. But there's a minus 1 with a weird power in front of it. What's that about? Well, that bit is determining whether it will be a plus or a minus at the start, basically. Because you notice the way, if you remember, what I told you was all of the even ones have a minus in front of it, and all of the odd ones have a plus in front of it. You'll notice that if you pick an odd number for k, if k is an odd number, and you take away 1 from it, then it becomes an even number. So if you put an odd number in for k, if k is an odd number, you end up to putting minus 1 to the power of an even number in the end. But minus 1 to the power of any even number is just plus 1. So if k is odd, this whole thing turns into plus 1. And you could check it. Just pick different odd numbers and put it in place of k there into the box there, and just see if you get anything other than plus 1 anytime, no matter what you put in, no matter what odd number you put in. Like 1, 3, 5, 7, 9, 11, 273, they're all going to give you just plus 1. That's all it's going to be. It's going to turn into plus 1. Now, in a similar fashion, if you did it where k was an even number going in, I fucked up my arrow, I apologize. If k was even, then we'd have an even number minus 1, but that ends up being odd. And then if you pick any odd number then, or if you pick any even number for k, and you sub it in here, the power turns into an odd number overall, and minus 1 to the power of any odd number will always be minus 1. So, what we can basically, now this isn't necessary for this question, but I just wanted to be mentioned for the next 3 questions or so, because I think it's relevant for all, well, at least one of them. I just wanted to get it out of the way here. Nothing to do with the actual answer here just yet, I don't think. But basically, k being odd means a plus. K being even means a minus will be involved. That's what I'm kind of indicating there. That's what I'm kind of telling you is going to be happening. So what's the question actually asked though? Part I haven't actually started part I yet, just so you know what I'm talking about. I'm just kind of explaining something that I don't think was really, it wouldn't really be something that's too common in the Leaving Cert. It's saying what's p dash of pi. I'm not going to do any differentiation. I'm just going to go, well, based on the pattern, whatever the last number was. So like for h, the last number was the 4s, and it ended up being minus 4. For g, the last numbers were 3s, and it ended up being minus 3. So for us, because the last thing is k, I changed it. I forgot to change it back, sorry. Because the last things are k's, it's just going to be minus k. Because k is literally just in the spot of the number that was causing the issues before. The like in place of the 4 here that led to the minus 4, in place of the 3 here that led to the minus 3. So in place here there's a k, so it's going to lead to minus k. That's all. And now that question's gone, done and dusted. Part 2. Let y be let y be the kth or final term of the function px such that y is equal to 1 minus 1 k minus 1 sine of kx over k. Again, now you have to remember here there's a few letters floating around. K is a constant. It does say it in the question, in fairness, where k is a constant. So k isn't changing. K isn't a variable. The only variable there is x and y, I suppose you could argue, but y is just kind of the cover all. Show that when x is equal to pi, dy dx is equal to minus 1. Well, I have to figure out what dy dx is first. So I'm going to differentiate. So that means differentiate the y thing, which is this guy, with respect to x, which is this guy. The k's are all just passerbys. You know what I'm trying to say. They're just, collateral damage. They're just in the way. So we're not going to differentiate the k. We're just going to differentiate the x. So this guy, because there's no x involved, he's just like a constant. He is literally like as if the number 6 was just written here in the front. If the number 6 was just written at the front, you would ignore it, kind of. Just write it down and differentiate this guy and get the answer in here, and then multiply that by the 6. We are going to do the exact same, but it's going to look horrendous because instead of a 6, it's minus 1 to the power of k minus 1. Now, what happens if we differentiate this one? Well, if you remember from above, I was saying if you had sine of 7x over 7, it would turn into 7 cos of 7x over 7, and then the 7s would cancel, and you'd be left with cos of 7x. In the same way, if we had sine of kx over k, we differentiated it, we would just put the k in the front, because again, don't forget, we're treating the k like it's just a number, just like any other number. We'd have it like that, but then the k here and here would cancel, and it would turn into cos of kx. So this just turns into cos of kx. Now, it says show that when x is equal to pi, so when x is equal to pi, dy dx changes to minus 1. K is always just k, so that's okay. Cos of k, because k is k, I almost wrote it wrong to confuse the issue. And then x is pi. Now for all values of k, for this one, I didn't like this one to come up in a leaving cert, because this is one where we have to say, well, we don't know what k is, so it kind of depends. And what we're going to do is we're going to kind of break it down. And we're going to say, this is like the k is odd kind of section. So this section on the left is going to deal with all the scenarios where k is an odd number. It's going to deal with all the sections or scenarios over here where k is an even number. Now if k is odd, if you remember, as we kind of discussed up here in the blue, if k is odd, what ends up happening is this guy turns into a plus 1. And that's fine. Perfect, right? However, if k is odd, cos of k pi, if you'll notice, always turned into minus 1. And you can check that again just by picking different values of k. I could explain to you what it always is happening, but I'm not going to do it here. If you want to ask me in person, I just don't think you care, to be honest, and it would just confuse the issue as well. But that's just always true. You can just pick different values of k that are odd and just make sure that that is true. But over here, in the k is even, I should finish this off. Sorry, let me finish this off first. So this thing, so if we're saying k is odd, we're still on the left-hand side. Sorry, I shouldn't start on the right-hand side yet. If we're on the left-hand side, we know this is always going to be plus 1. And we know that this is always going to be minus 1. So then it will always break down to plus 1 multiplied by minus 1, which is minus 1, if k is odd. Hopefully that's okay, which is. So, and that's what they wanted to do. They said show that it's always going to be -1 no matter what k is. Well, if k is odd, it's definitely going to be -1. But now we're going to investigate the k being even as well, because hopefully this should also be -1 as an end result. Well, we said up here in the orange, up here, I can't remember if you can see my cursor or not, but up here in the orange at the top, we said that if k, if you put that in as an even number, you get -1 as an answer. But we also saw that if you do cos of kx, where k is even, so earlier when we did the cos of 2x over, or sorry, cos of 2 pi over here, and we did cos of 4 pi over here, you always end up getting +1. And you can try that in your calculator just to play it safe if you don't just trust me outright. That will always be +1 if you write it exactly like this, if you're in radians mode on your calculator, and if the k is replaced with an even number, you'll always get a +1. But then that means this guy will always be a -1, and this guy will always be a +1. So we're left with -1 times +1, which I'm sure you'll have guessed is -1. So we've just shown that even if it's even, the answer will always be -1. If it's odd, it will always be -1. And every number in the galaxy, whatever, yeah, we won't get into it. Every number is odd or even. So therefore, every single number, every single value, no matter what it is, will always end up being -1, as it asks in the question. That's a very tough question. Now, that's something that would have really only been encountered in college, I feel like, in your generations. Like maybe in the older Leaving Cert they'd have said stuff like that, where you have to actually think about it and break it down rather than just kind of go, oh, I know a formula for that, or oh, I've done this question before. It was actually like you have to stop and think about it, which is annoying because you guys don't really know how much of it is. First off, you might not know the stuff anyway, but let's say you do know the stuff, you might say, well, is this enough? Are they going to trust that if I say this, they're going to know where that came from, or whether do I have to explain why I know this is true at the same time? Part 3. As the number of terms k becomes very large, describe what happens to the tangent at p, or at x equals pi of px. Basically what they're saying is what happens if on the graph you went to pi on the x-axis, what's happening to the slope of the curve at that point as k gets bigger. And what's going to happen is, as I said earlier, if k is small, the slope is minus k. The slope is always minus k. Let's get this out of the way. The slope is always minus k. So if k is small, you'll have a bit of a slant. As k gets bigger, the slant will get more and more, come on now. The slant will get more and more steep, a bit more obvious, if you know what I mean. Like it's not going to just be as tilted. But if it just keeps going and going and going and going, it eventually just keeps going towards a straight line, going straight down. Now it'll technically never exactly be a straight line going straight down. Technically, now I know that's zipped to a straight line straight down. Technically, it'll never be a straight line. But what you would say is, in English, it's getting closer and closer and closer to just being a vertical line. Because the bigger the number after the minus, the steeper it is, and k just keeps increasing. So that's what happens there. Now, I'm going to just make a break here so I can make the videos easier. I might just do, yeah, it doesn't matter. Talk to you in paper 2.